If you like audiobooks or audio shows, check out a free trial of Audible. Just click the link in the description.
Welcome to MINDSHOCK. This is Bruce McGuire here with
Maxwell Powers and Sid Irwin.
Yes, Sid, you haven't been on with us in a while, but we need your Mensa IQ for the kickoff for this time travel podcast series. This is episode 1, The Nature of Time Travel, and we will be going over the ins and outs of time travel, the various theories and paradoxes, and all that they entail. So once again, if you like our podcast, you can donate to our PayPal. Just check the link in the description. Make sure you subscribe to the channel, hit the bell for notifications. If you like the video, hit the like button. Feel free to share it across social media platforms. If you have any questions, comments, criticisms, or thoughts of any kind, feel free to leave them in the comments section. Also, like our Facebook page, and you can check us out on Reddit, Twitter, and Patreon as well. All right, so Maxwell, what do you know about time travel?
I just know that I like the topic. I like all the movies based on time travel.
Maxwell Powers,
Uh,
a movie fan? No way.
Back to the Future, all three, especially the first one, and uh, anything that has to do with time. You know what I like the most though? Like in my real life, like if I touch or open an old book that's like 100 years old or something. To me, that's kind of like semi time traveling because I'm kind of like
Wait, you
touching
said
something
in
that's
your real life? What about in your fake
well.
life?
Oh wait, well, in my fake life, well, actually,
Are
um,
you trying to say you're a time traveler, Maxwell Powers? Are you a visitor from the future? Or are you
oh
a visitor
man,
from the past?
I actually have uh this book. Let's see, How to Win Friends and Influence People by Dale Carnegie. It's it's really old. It's like brown and like it's falling apart, and it's about uh when was it printed? Man, this thing's old. It's like turning yellow.
Wow.
Yeah, it doesn't say, but anyway, like I open this book and I think of all the people that read it, from different libraries and stuff, and
Yeah, that's not
yeah,
exactly the kind of time travel we're going to be
um,
talking about, Maxwell. All
yeah,
right,
no,
Sid.
I'm just saying that's kind of
In your vast knowledge of various topics and your various degrees in various fields, what do you know about time travel? Sid, did you time travel away from us?
Sorry, yes, I did. I did do that. With time travel, I like to think it's like Maxwell feels a very interesting topic, but it's a very messy one too. Especially with all the different interpretations. Some people believe that when you time travel, say to the future or past, you alter the timeline, thus either create a new timeline or just change the current one you're in, or the fact that some people interpret time travel could just be a consciousness shifting through time to make changes
Yeah,
as opposed to an actual physical form,
that's a
which could.
very interesting one that when I first started researching time travel years ago, I had trouble wrapping my head around that one, but at that time I also hadn't done as much research into the nature of consciousness itself and in quantum physics and all of those things and the nature of reality and how you experience it. But that is indeed a tricky one. But let me see if I can mind shock your brain, Sid, which I know is a very difficult thing to do. What if what if all of the time travel theories, paradoxes, timelines, what if they're all true simultaneously? So, like, let's say you go back in time, that maybe there was only one timeline and it created an infinite timeline, or if there were infinite timelines, it still created more, or there's a single timeline with a bunch of people living on it, and then there's also like almost an entire universe of existence that's separate from that one with multiple timelines. So, what if all of it is true?
That could, yeah, it could highly be possible.
That's a mind bender. Maxwell, what do you think about that?
um I forgot what you said. What would
Maxwell, All right, well, we're going to go over it in detail as we delve into the different time travel theories. If you're new to time travel, we're going to go over the various ways that are theorized that one could travel through time, different mechanisms. And this is an article from on space.com by Elizabeth Howell, published November 14th, 2017. It's called Time Travel Theories, Paradoxes, and Possibilities. Time travel, moving between different points in time, has been a popular topic for science fiction for decades. Franchises ranging from Doctor Who to Star Trek to Back to the Future have seen humans get in a vehicle of some sort and arrive in the past or future ready to take on new adventures. The reality, however, is more muddled. Not all scientists believe that time travel is possible. Some even say that an attempt would be fatal to any human who chooses to undertake it. How would they know that? Anyway, okay, understanding time. What is time? While most people think of time as a constant, physicist Albert Einstein showed that time is an illusion. It is relative. It can vary for different observers depending on your speed through space. To Einstein, time is the fourth dimension. Space is described as a three-dimensional arena which provides a traveler with coordinates such as length, width, and height showing location. Time provides another coordinate, direction, although conventionally it only moves forward. Conversely, a new theory asserts that time is real. We won't get into that. Einstein's theory of special relativity, or do you guys want to get into that?
I'm fine with either way.
I'll get into it.
Oh, this is going to be such a vast aside, and we're just getting started. All right, but this is MINDSHOCK, so I guess we can get into it. Okay, so here's another article. Do black holes create new universes? Q&A with physicist Lee Smolin. This was actually published way back in May 29th, 2013. Most physicists think time is a subjective illusion, but what if time is real? The universe may have been born inside a black hole, and the black holes in our own cosmos might be birthing new universes of their own. If one physicist's controversial idea about time is true. Going against the standard view of most scientists, theoretical physicist Lee Smolin has suggested that time is real rather than the illusion that Einstein's theory of relativity makes it out to be. Smolin, who's based at Canada's Perimeter Institute for Theoretical Physicists, outlines the idea in his new book, Time Reborn. Space.com caught up with Smolin recently to learn about his theory and then real nature of time. What does it mean for time to be real or not real? Isn't time obviously real? Smolin says, in the physicist's conception of nature, as developed from Newton to Einstein, time becomes a secondary concept. It becomes replaced by a notion of computation, so that a process carrying out in time and causing things to happen becomes modeled by a logical computation. Logic and mathematics are outside of time, and therefore, if that modeling is completely accurate, time is unreal. For example, Einstein is famously quoted as saying that people who understand physics know that the distinction between the past, present, and future is only a stubbornly persistent illusion. Do you agree with that, Sid?
To me, all I can do is just hearing that, thinking about it, is that I can somewhat agree time is real. Only, and let me explain. I feel more like rather instead of time not being real, it's more about one's perception of time. In the sense of, I remember once sitting through a horrible movie with my sister I was watching. What was it? The Blair Witch Project. That's right.
Not a fan?
Not a fan at all. Absolutely stole
Maxwell,
by
was
the
that your favorite movie, Maxwell? Did he just say it's your favorite movie?
No, no. It was okay.
I've actually never seen it.
don't
I couldn't get through the trailer. But anyway.
don't. Either way, I sat there and I watched that movie, taking in all that, and I thought literally a half hour must have passed from beginning to finish. I left that theater realizing I lost an hour and a half of my life, and I was just like, how the hell did that happen? Like, time made no sense. It felt like 30 minutes, and yet an hour and a half went by. So, by my perception, though, That's why I assumed it would be 30 minutes. But for the rest of the world, it was a full hour and a half
Well, you know
where they
what's
could do
interesting?
whatever they wanted.
What's interesting about your perception is that I've been reading a lot about time and time travel as well, and it always used to kind of hurt my brain a little bit because I've heard that time is just the way your brain organizes information. So true reality is whatever it is, and your brain just organizes it in a certain order, but there's no real proof it happened in that order. So if everybody's brain is organizing it in that way, then time would appear to be real to everybody, even if it's not. Obviously, very difficult to prove. But Maxwell, thoughts?
Well, what's interesting when Sid was talking about his experience, that he wasn't interested, yet time went fast for him as a perception rather than the other way around. Because usually when I hear people talk about like oh wow, time went by so fast, they were enjoying the moment. Does that make sense? I,
Yeah,
I'm just
yeah.
I just found that interesting. Like he found it so boring that an hour and a half went by without knowing it.
Well,
I
yeah,
don't know.
most people.
Maybe there's an extreme. Like if you get really bored and upset, that your
Well,
brain makes
and
it.
zoned out Maxwell Power style, where you don't even know what happened, and then it's already like 30 episodes of a podcast series went by, and you
Maybe.
can't remember anything.
Wait. Did you like daydream like part of it, and that's why time went fast? Maybe that's what happened.
Not even. I was watching that movie intently, discussing how bad this is and waiting for something to happen.
Oh man.
Like,
Okay. So,
Oh man.
but I see Maxwell's point though. Usually, like if you were, especially when you're a kid in school and you can't wait for the bell to ring for class to be out, that last minute or two really feels like an hour.
very true.
So that's, yeah, again, it's just the way the brain perceives everything. And I guess the question for physicists would be to how to prove anything for sure, because then you obviously have the observation problem where nothing's really happening unless there's an observer and all these things. And full disclosure, Maxwell and I kind of dig deep into Einstein's relativity. And I don't know about Maxwell, but I'm pretty critical of Einstein's relativity. I'm definitely going to take the side of Nikola Tesla, who basically dismantled most of Einstein's ideas and basically called them nonsense.
Talk about Nikola Tesla's stuff versus Einstein's stuff. That would be interesting because I totally forgot what you said about that.
We only discussed it so many times. Yeah, we have to stay focused here. We're already on an aside of an aside. So like let's get back to this. So, when you say time is real, in contradiction to these ideas by Einstein and others, then what does that mean? Smolin responds, first of all, that the experience that we have of being in the present moment, which is one of a flow of moments succeeding each other, is not an illusion, as Einstein and others asserted. It's the deepest clue we have as to the nature of reality. Reality is structured to a series of moments so that anything that is real in a moment of time. And if something appears to persist in time, that's because it's continually renewing in time, in the moments of time, which are the reality of existence. Any truth about the world is a truth about the world within time. There are no timeless truths. And most importantly, there are no laws of nature that are outside of time. Everything changes, including the laws. That's kind of deep. I've actually never read this Q&A
Huh.
before. But that is very, very interesting. He's basically saying everything is fluid and any kind of timeless truth only appears timeless because it's renewing as true in that moment, and in another moment, it might not be true.
Which I can see.
Yeah, if you guys are interested in podcasts, obviously Joe Rogan has one of the most popular podcasts, if not the most popular. He actually had a guy, George St. Pierre's trainer, Firas, and they started talking physics, and he kind of schooled Joe Rogan on some of his assumptions. But one of the interesting things I don't know if have you guys heard that interview? I think or that podcast. I recommended it to Maxwell. I don't know if you have ever actually listened to it though.
No.
So he basically equated science and religion similarly, where you have faith in science that an experiment will repeat itself based on those certain parameters. So, for example, if you're doing chemistry, you mix some kind of chemicals, it causes a reaction, and even if you do it a million times, and it's the same reaction a million times, you're still having faith that it'll have the same reaction again. Now, in the span of obviously a human lifetime or all of human existence, if that's all rounded to zero, what this guy's saying is pretty interesting. He's saying the laws of nature change. So what could have been a law before is not going to be a law after due to the constantly changing universe. That's pretty interesting, right?
I believe so.
Yeah, it's interesting.
So it's kind of almost like one of the paradoxes in time travel. If time travel ever exists in the future, then it already exists now and at all times in the past.
It does.
So, which that's kind of strange if we're living one real timeline and there's only one timeline, or even if there are infinite timelines or infinite dimensions, even in the multiverse theory, if that still means that up to a certain point in our time, there was no time travel. However, at a certain point, there was, and then it always was. That means that the past reality was true both ways. All right, so the next question. So, how does this concept help us understand the laws of nature? Smolin says the main reason why I advocate this new view of time is because it may make the laws of nature explicable. And by that, I mean the scientific answer to the question of why the laws of nature, as we observe them, have been selected to be what they are. If the laws are timeless and eternal, then there's no way to explain the choice of laws. As far as we understand it, the laws might easily have been different in many different ways. The masses of the elementary particles might have been different. The strength of the forces might have been different, or there might have been altogether different elementary particles and forces. I believe, and this is the result of an argument which is carried out in the book, that the only way within science of explaining the laws of nature is if the laws of nature are the result of dynamical evolution in time. How does your theory of the dynamical evolution of the universe work? Smolin says the idea is that the universe evolved in a way which is very analogous to natural selection in a population, say, of bacteria. To do this, the universe needs to reproduce itself. And I took over an older idea by John Wheeler and Bryce DeWitt, who are pioneers of quantum gravity. Their idea was that black holes become the seeds of the birth of new universes. John Wheeler had already speculated that when this happens, the laws of nature are reborn again in the new baby universe. He called it reprocessing the universe. What I had to add to this to make it work like a model of natural selection was that the changes passed from parent to child universe are very slight, so there can be an accumulation of fitness. This hypothesis leads to the conclusion that assuming our universe is a typical member of this population of universes as it develops after many, many generations, that the universe is going to be finely tuned to produce many black holes. That leads to the next hypothesis that if you change the laws and the numbers that specify the laws, then typically you're going to make a universe that makes less black holes, and that's something that leads to predictions that can be tested. That's the theory that I call cosmological natural selection. Did you get all that, Maxwell?
I got cosmological natural selection.
That's it?
I don't know what that means.
He just explained it right preceding that, right? He's basically saying that a universe spawns baby universes. And that
Gotcha.
and
That's
that
cool.
the laws of nature of the universe change. Like
Okay.
That's freaking awesome.
almost
So,
almost like traits being passed to an offspring for survival so they can vary. Even if they vary very little over time, it could be a lot. What do you think, Sid? Have you ever heard of this theory before?
no, I never have asexual universes that reproduce. Interesting.
Oh
It's
man,
kind of
that's
Very interesting.
awesome.
well. This is MINDSHOCK.
They make a
Mind
movie out of
shocking.
that, or
Why do you think they would make a good movie?
I don't know. I think so.
It would hurt
Maybe.
people's brains. All right, so how would these universes pass on their traits to daughter universes? Smolin says, At the level in which I proposed this theory, I didn't answer that question, just like Darwin had no idea how inherited traits were inherited because he didn't know anything about the molecular basis of genetics, which was only discovered with DNA. So I was able to make those predictions without specifying the microscopic basis of inheritance in cosmology. Just how are new universes born inside black holes? Smolin says a star that collapses into a black hole very quickly squeezes down to an infinite density and time stops. That's according to general relativity. And basically, that moment when time stops is deferred by quantum mechanics by quantum uncertainty. And rather than collapsing to infinite density, the star collapses to a certain extreme density and then bounces back and begins to expand again. And that expanding star becomes the birth of a new universe. The point where time ends inside a black hole becomes joined to the point where time begins in a big bang in a new universe. Now, okay, I have to do another aside on top of this aside, which was an aside from another aside. But Sid, where are you with Einstein's relativity? Because there was actually there have been a number of physicists, like PhDs from MIT, Harvard, wherever, they've debunked relativity point by point, like they just systematically destroyed it.
Been a while since I thought about that one.
So basically, all of Einstein's so-called theories or assumptions, and most of them weren't even his, he stole them from other people. But I mean, he was a patent clerk. There was a lot of stuff going over his desk. He so-called borrowed, or I guess took some of those ideas, republished as his own. But I mean, he even admitted that his own theory is all a house of cards. He's not sure of any of the ideas. Like he was a funny guy. Like he joked around about how he was wrong about everything all the time and nobody listened. But
if I remember, the theory of that was when I talked about how well, yeah, time's an illusion, right, and all that.
well, yeah, gravity and space
Yeah.
time and curved space time, all of that.
I don't know. I'm gonna keep it simple. I mean, if time doesn't exist, then why do we age? If time doesn't exist, there should be no passage time for the aging process to occur. So technically, we should all stay the same age at this point.
Well, what about all the undiscovered laws of physics, which might be infinite? That do they account for what you're saying? So like whenever I approach anything, I always ask, well, wait a second, what makes you think we know we have all the pieces of the puzzle? If there's some major pieces missing, how can you like you're assuming that a question can be answered with pieces that we have? Or I'm not saying you are, but when you pose a question like that,
Yeah.
the only way to answer it would be with how can you answer it with pieces you don't have because you don't know that yet?
Very true. I'm about to admit that fact. I have no idea. I'd have to do more research, and if not, discover it on my own. Prove my point.
All right, here we go. The guy's name is Run Z Cow, and so he published The Great Mistake, Relativity.
Oh wow.
Yeah, and you could also he also makes YouTube videos, so you can check him out. And he has he makes everything in very simple terms on how he just debunks relativity. I've watched his videos multiple times. He's really good at keeping it simple and pointing out the flaws in a very basic fashion and why, and just the assumptions that Einstein made, or either intentionally, not intentionally. There's a whole bunch of conspiracy rabbit holes to do with Einstein as well. Yeah, so I just wanted to quickly say that. So I don't think relativity should be used as gospel truth because a lot of these time travel theories are kind of depending and piggybacking on relativity. So if none of that is true, or most of it's not true, then all of this could possibly not be true, or it could still be true, but for other reasons, not relativity. Once again, we don't know what we don't know. So does that make sense, Maxwell?
Yeah, can you repeat that real quick?
I'm gonna tell you, I guess, in a fashion of. I can't think of what the movie is
All right,
called.
let's keep it. Let's keep it. Oh, you could answer, Sid. Maybe you could explain things better, so Maxwell could actually retain it because he seems to have some. Maybe it's just my voice,
Ooh,
but Maxwell
Pulp
has trouble
Fiction.
retaining my voice.
Maybe I was just gonna make a Pulp Fiction reference, or even Boondocks reference. Was it there known knowns and there are known unknowns and there's unknown unknowns, which are just
Perfect.
things that we don't know. So
Perfect. Yes, exactly. So when you're building a house of cards like relativity, you could say it's true. And a lot of people think there was a consensus at the time. There wasn't. Some of the greatest minds and physicists of that time era, that time period, they disagreed with relativity outright. And Einstein was just chosen as the so-called establishment. And you know what's funny? Like, we're not going to go into Einstein versus Miller, but in that whole debacle, when it was finally like when he was publishing his paper on why Miller was wrong and Einstein was right, guess who they consulted for that paper?
this is
Tesla?
wild.
What?
I don't know. Who?
Einstein.
Okay.
So that, which is kind of, I mean, if that's not a conflict of interest, I don't know what is.
Yeah.
And then that scientific, like, so the scientific establishment was basically like he became their poster boy, and he said Miller was wrong. But even Einstein, like, he was such a joker. Like, he's always sticking his tongue out in photographs and making these weird comments. Like, I think he knew, and he was trying to give people clues as to like the fraud of it all just for kicks. Kind of like a serial killer leaves his calling card. I always say that. Or the serial killer makes calls to the police. He doesn't have to. He can get away. He just likes the game. So some people postulate that Einstein knew his fraud the whole time. And we talked about this before. You know, the great hoax where the eclipse data of 1919, and that was falsified by some guy who claimed he had the technology to get eclipse data from an eclipse, and then he said that matches Einstein's theory. Therefore Einstein is correct. Everybody bought it. Einstein gets his Nobel Prize off of fraud data, admittedly fraud after the fact, and like, it's not disputed. It's all fraudulent. And then nobody asks any questions, and then Einstein himself becomes the poster boy and starts being the reference for debunking his adversaries. Like, shouldn't you have a neutral party do that?
Ah, that's interesting.
So yeah, the whole foundation of the past century of physics is all built on fraud. So again, I'm not even saying necessarily Einstein's wrong. There's a lot of people who have spent their whole lives dedicated to this, and this Run Z Cow guy, he he lays it out in pretty basic terms. So all the listeners out there, if you guys have time, check out some of his videos on YouTube. He's got some short ones, the time dilation debunked, and all of those things, and he lays it out really, really simple. So, but anyway, let's get back to this.
That's interesting that Einstein admitted to the fraud. That's pretty cool.
He didn't admit to the fraud. What do you mean?
Oh, I thought you said like
The
he
guy?
admitted.
No, it was
Gave clues.
the guy that
Yeah,
measured
that
the
guy
eclipse
called up.
data. Einstein might have not even
Ah,
been aware of that. He might have just thought it was funny. Like, let's say he comes up with if he came up with the fraud theory. I'm not saying this is true, but if he came up with a fraud theory, and then this guy some really popular guy, and Maxwell and I have discussed it on a bunch of podcasts, but this guy all of a sudden comes out of the woodwork saying, "Oh yeah, I got the measurements. Einstein's theory of relativity is correct based on the eclipse data." How hard would Einstein have been laughing at that time? Or
uh,
some people believe there was this mass conspiracy, and they were he knew about it, and they were in on it together. And yeah, once again, we were gonna do a dedicated Einstein podcast. We haven't gotten around to it, but we should definitely have Sid on for that one. Okay, so let's get back to this article. Does this idea have testable predictions? Smolin says, I did make two predictions which were eminently checkable by astrophysical and cosmological observations, and both of them could easily have been falsified by observations over the last 20 years, and both have been confirmed by observations so far. One of them concerns the masses of neutron stars, and the prediction is there can't be a neutron star heavier than about twice the mass of the sun. This continues to be confirmed by the best measurements of the masses of neutron stars. The other prediction has to do with the cosmic microwave background radiation and the hypothesis of cosmological inflation. The observations of the Planck satellite are completely consistent with the version of inflation that cosmological natural selection supports. You know, another interesting point is, like, these are all just guesses. Like, can they really know how much a neutron star weighs? Like, you're just building theories on theories and making like guesstimates. And then for some reason most people just lap it up as irrefutable fact just because some astrophysicist said so. The appeal to authority fallacy.
Hmm.
How do you view all that, Sid?
Sounds like a lot of jive, but a very smart jive. Mm.
All
Well
right.
spoken jive.
So now that we took the quick aside into time possibly being real, let's go back to the original time travel article so we can go with the normal theories, the established theories of time travel. So, Einstein's theory of special relativity says that time slows down or speeds up depending on how fast you move relative to something else. Approaching the speed of light, a person inside a spaceship would age much slower than his twin at home. Also, under Einstein's theory of general relativity, gravity can bend time. Picture a four-dimensional fabric called space-time. When anything that has mass sits on that piece of fabric, it causes a dimple or a bending of space-time. The bending of space-time causes objects to move on a curved path, and that curvature of space is what we know as gravity. Both the general and special relativity theories have been proven with GPS satellite technology that has very accurate timepieces on board. Once again, Run See Cow debunks that. But anyway, the effects of gravity as well as the satellite's increased speed above the Earth relative to observers on the ground makes the unadjusted clocks gain 38 microseconds a day. Engineers make calibrations to account for the difference. In a sense, this effect, called time dilation, means astronauts are time travelers as they return to Earth very, very slightly younger than their identical twins that remain on the planet. Through the wormhole, general relativity also provides scenarios that could allow travelers to go back in time, according to NASA. The equations, however, might be difficult to physically achieve. One possibility could be to go faster than light, which travels at 186,282 miles per second, 299,792 kilometers per second, in a vacuum. Einstein's equations, though, show that an object at the speed of light would both have infinite mass and a length of zero. This appears to be physically impossible, although some scientists have extended his equations and said it might be done. A linked possibility, NASA stated, would be to create wormholes between points in space-time. While Einstein's equations provide for them, they would collapse very quickly and would only be suitable for very small particles. Also, scientists haven't actually observed these wormholes yet. Also, the technology needed to create a wormhole is far beyond anything we have today. Or do we? If the military is about 50 years ahead, what technology level are they at?
Right. So the wormhole theory is always interesting because they don't just use it for the concept of time travel, but also for just high speed, distance travel in and of itself, which I find interesting. Any mention of like time affecting the person going through it.
Well, you've heard of Moore's Law, right?
Yeah, definitely. I think you should talk about it though for our viewers so they're aware.
Maxwell, you're an expert in Moore's Law, right? We talked about it many times, right?
I don't remember Moore's law. Oh wait, is that the doubling of technology and shit?
Yeah, I mean, it was originally referred to the number of transistors on a microchip doubling every 2 years,
Oh, that.
while the cost being halved. So, in general, it's just processing power accelerates exponentially. That's the basic gist of it. So, we also have to factor in the military's always 50 years ahead of time. Now, what greater weapon could there be than time travel for the military? So, do you believe, like, what do you think about all those? I mean, we have MK Ultra. Some people allege that there were also time travel experiments, and we'll be getting into these in future episodes. But do you believe the government has been at least attempting to travel through time, if not successfully?
I could. Won't be surprised.
Maxwell?
Can you repeat that question?
Maxwell Army. I just asked if you believe that the military is either working on time travel technology or have already achieved it. Because if their technology is 50 years ahead of time, does the technology in 50 years civilian tech, in 50 years of civilian tech, will that be good enough? Because that's where the military is at right now, roughly. At least, maybe it's far advanced. Who knows? We're just the civilians. We're not privy to all that top secret declassified information unless you're Jr.
Yeah, I have no idea.
Is that going to be your new mug, Maxwell? I have no idea. Or can you repeat the question? Okay, let me finish this introductory article because we're just getting started. Alternate time travel theories. While Einstein's theories appear to make time travel difficult, some groups have proposed alternate solutions to jump back and forth in time. The infinite cylinder theory. Astronomer Frank Tipler proposed a mechanism, sometimes known as a Tipler cylinder, where one would take matter that is 10 times the sun's mass, then roll it into a very long but very dense cylinder. After spinning this up a few billion revolutions per minute, a spaceship nearby, following a very precise spiral around this cylinder, could get itself on a closed time-like curve, according to the Anderson Institute. There are limitations with this method, however, including the fact that the cylinder needs to be infinitely long for this to work. Black holes. Another possibility would be to move a ship rapidly around a black hole or to artificially create that condition with a huge rotating structure. What are they doing at CERN? You think they're doing time travel experiments at CERN?
Could be. I find interest so far with these two theories. What seems to be the base quantity that's important to have, like the aspect or ingredient needed to make these all work is infinity. It's interesting.
Is what?
You need something infinite. AKA
Oh,
just it's
or
something infinite.
I mean that's the theory. Well, I mean these are all
Hey, for
theories
those
and theories, but the black hole theory not necessarily. So to create a condition with a huge rotating structure, around and around they'd go, experiencing just half the time of everyone far away from the black hole. The ship and its crew would be traveling through time. Physicist Stephen Hawking wrote in the Daily Mail in 2010. Imagine they circled the black hole for 5 of their years. 10 years would pass elsewhere. When they got home, everyone on Earth would have aged 5 more years than they had. However, he added, the crew would need to travel around the speed of light for this to work. Physicist Amos Iron at the Technion Israel Institute of Technology in Haifa, Israel, pointed out another limitation. If one used a machine, it might fall apart before being able to rotate that quickly. Cosmic strings. Another theory for potential time travelers involves something called cosmic strings, narrow tubes of energy stretched across the length of this ever expanding universe. These thin regions left over from the early cosmos are predicted to contain huge amounts of mass and therefore could warp the space time around them. Cosmic strings are either infinite or they're in loops with no ends, scientists say. The approach of two such strings parallel to each other would bend space-time so vigorously and in such a particular configuration that it might make time travel possible in theory. Now we get to the most popular one, time machines. It is generally understood that traveling forward or back in time would require a device, a time machine, to take you there. Time machine research often involves bending space-time so far that time lines turn back on themselves to form a loop, technically known as a closed time-like curve. To accomplish this, time machines often are thought to need an exotic form of matter with so-called negative energy density. Such exotic matter has bizarre properties, including moving in the opposite direction of normal matter when pushed. Such matter could theoretically exist, but if it did, it might be present only in quantities too small for the construction of a time machine. You know what's weird? That statement in and of itself. If they don't even know if they could theoretically exist, how would they know that it would be present in too small quantities?
very intriguing, but aren't they basing off of just the popular thought and never self to theorize in general? Which I guess I'm going off when basing off against popular media, since they
Well,
seem
let
to
me let
often.
me let me give you an easy example because Maxwell and I talked about this in our Bigfoot episodes, in our digital analog episodes. Let's say before people discovered there was infrared in the spectrum of light.
Uh huh.
Nobody ever knew about it. But like it exists and it exists everywhere. It's just the human eye can't really pick it up good
Pick
enough
it
to
up.
see without special equipment. So
Right.
if you're theorizing that negative energy density or other types of matter or energy exist, how would you know? Like it's kind of silly to even speculate on the quantity it would exist in, right?
Without actually knowing that it exists. I get that.
Yeah, so that's kind of weird. Maxwell, thoughts?
Um, yeah, I got nothing.
It's another one right there.
Okay, however, time travel research suggests time machines are possible without exotic matter. The work begins with a donut shaped hole enveloped within a sphere of normal matter. Maxwell, you like donuts. You should be able to follow this, right? Inside this
Uh,
donut shaped vacuum, space time could get bent upon itself using focused gravitational fields to form a closed time like curve. To go back in time, a traveler would race around inside the donut, going further back into the past with each lap. This theory has a number of obstacles, however. The gravitational fields required to make such a closed time-like curve would have to be very strong, and manipulating them would have to be very precise. All right, they also address the grandfather paradox. So, real quick, if you're new to time travel, if you're not, I'm sure you've already heard of this. So, if you go back in time to kill your grandfather, you would have never been born, so you wouldn't have been able to go back in time to kill your grandfather. So, how would it be done? So, Maxwell, thoughts on that?
about killing your grandfather and like that loop.
Yeah, the paradox, the grandfather paradox.
Um, uh, yeah, I don't know.
Sid, what do you got?
Um, Makes sense. And of course, with the separate timeline theory, where going back and then killing your grandfather even may result in you not being born. That's just starting a new timeline where you won't be born. But that other time exists still where you would have gone back and killed your grandfather to start this up. It's really funny.
All right, here's another mind shock for everybody. Let's say there are infinite universes in the multiverse theory. So, is there a point? Obviously, in some of the universes, time travel wouldn't exist yet. So, when when time travel exists in none of the universes, is that the way the infinite universe existed before time travel was discovered? And then after it was discovered, it simultaneously exists across all infinite universes?
Very
Or
trippy.
are certain universes where there is no time travel, but in other universes there are. And when time travel is discovered in the universes where it wasn't discovered, now it exists backwards in those infinite universes?
Huh.
Or are there always universes that exist where no time travel is ever created? Obviously, there'd be at least one like that. But if we're talking infinite on infinite, that means there would also be infinite where time travel never existed, right?
I can see that, yeah.
Maxwell, did you follow that?
No, not really. But what's the question?
Ah! Oh man. All right, well, let me go over this grandfather paradox in this article. Besides the physics problems, time travel may also come with some unique situations. A classic example is the grandfather paradox, in which a time traveler goes back and kills his parents or his grandfather, the major plot line in the Terminator movies, or otherwise interferes in their relationship. Think Back to the Future, so that he is never born or his life is forever altered. If that were to happen, some physicists say you would not be born in one parallel universe, but still born in another. Others say that the photons that make up light prefer self consistency in timelines, which would interfere with your evil suicidal plan. Some scientists disagree with the options mentioned above and say time travel is impossible no matter what your method. The faster than light one, in particular, drew derision from American Museum of Natural History astrophysicist Charles Liu. That simply mathematically doesn't work, he said in a past interview with sister site Live Science. Also, humans may not be able to withstand time travel at all. Traveling near the speed of light would only take a centrifuge, but that would be lethal, said Jeff Tolackson, a professor of physics at Chapman University in 2012. Using gravity would also be deadly. To experience time dilation, one could stand on a neutron star, but the forces a person would experience would rip you apart first. You know, people said the same thing about space travel, that humans are just incapable of existing outside of the Earth's atmosphere.
Huh.
So, you know, the negative Nancys of the world have always said something was impossible until it was done.
Think about negative Nancy. You technically could go back in time and kill your grandfather and still exist.
Wait, what was that?
I mean, technically, you still could go back in time, kill your grandfather, and still exist.
Oh, right, because you came from the other timeline?
No, not even. It's still the same time. Just kill your grandfather after he has your parents. That's all.
Oh, I see what you're saying. So even if there's only one timeline, you're still you. So you're the matter. You're your matter.
Yeah.
What do you think about that, Maxwell?
Yeah, I mean, I guess it depends on what time you travel to. Like, if you kill your grandfather before your parents were born, or
Well,
before
let's
you
discuss
before
that.
he's
Let's discuss that. Can you exist? Let's say you kill your grandfather when he's a child. He never has your parents, but you still exist because you're the matter that went back in time. So even though you don't exist, like you're still
Yes.
you. You're still
Yes.
existing.
you're probably adopted.
Or just because you moved outside the timeline, separate
Right.
yourself.
So that's the other thing with time travel. Once you travel, you're no longer trapped in that timeline. So if you can
So you
move,
so you can never go back. Is that what the thing is? Like, you can never go back to your own universe once you travel.
no, but let's say
As
you could. Let's say you did though, because you're existing outside of the timeline, even if you go back, right? Sid, are you following?
I'm following.
So you went back, so your parents never existed, but you still exist because you're the point in time when you went outside the timeline. You'll always be that because you existed
I
up
like
till
that.
that point.
Yeah. Huh.
Similarly, like here's another issue with time travel that I don't hear discussed too much. Let's say you go back in time to before you were born. How would that be possible if you're part of the timeline? Like it seems like if you can travel through time, one of the necessities, again, this is just from my understanding, which could be wrong, obviously, I'm not a time traveler. Or maybe I am. Maybe that's not obvious. So once you initiate the time travel, you're not bound in any way. So if you go back to, let's say, 1,000 years ago, you never existed in that time, but you could still go there. So therefore, the grandfather paradox wouldn't necessarily apply because your matter is your matter. You exist as it. So it no longer matters what you do or what you don't do because you're existing outside of time.
Very true.
If that's
Uh,
how it works. But
If that's how it works, yes.
yeah.
Yeah, repeat that last part. That was pretty cool, but I don't get it.
What a shocker. Sid, you wanna take a stab at it?
Explaining this. Um.
Just a quick recap for Maxwell. He said he doesn't get it.
Okay. In a sense, I guess possibly put it. Once you travel through time, you stop existing, I guess, in that said timeline, or aka time doesn't really hold you down anymore. So at that point, whatever happens in time will have no effect on you. So I mean, pretty much that's really it. So anything you can literally do anything, and then whenever you travel back forth, whatever, you're unaffected.
You become God. Holy shit.
Well, not really. You could still be killed at
Uh,
any time
well,
by anybody.
yeah, it's just that, aka such aspects like again, killing your grandfather, thus your parents, or whatever, killing you in said timeline doesn't affect you because you're no longer in it. It's like you become an observer of sorts.
Oh, but that was like the first point, like that Bruce made, is you just come out of timeline, you're not affected. You become you. Uh,
So that was the point he was going for.
Yeah.
yeah.
Here's another interesting point that I don't hear discussed enough. So you guys have seen what is it? I think it was the 1994 movie Time Cop with Jean-Claude Van Damme.
Oh god,
The same matter cannot occupy the
yeah,
same space at the same
space
time.
and time.
That is interesting. You don't see that tech because in some time travel movies, like the protagonist is fighting himself in the past. So let's say you go back in time at a major life event. how does that work? Because if you're you and you go back in time, is that other you you? And what happens if the same matter does occupy the same space?
That is intriguing. But since it's you that's, I'm guessing, a different age, would that technically be the same matter?
Well, that depends on whether time is real or not.
Very true. But I mean, apparently the body might undergone a change. And technically, if it's talking about the same matter existing in the same space at the same time, if we're talking about you existing outside of time, your future self in a different time, does that apply even?
Well, here's the other thing that I never really understood. Let's say you touch your past self. You're not putting your hand through your past self. It's still not really the same exact space, is it?
Yes.
Because
No,
unless
is it
yeah, unless
that
you actually transport back in time and you appear like partially inside the space of your past self, that would be that.
you
But
know what? It's very true. Thinking about it, it's very true. Yeah, the same matter cannot. Oh, so but actually, you know what? That's funny. They're saying the same matter cannot occupy the same space at the same time, right?
that's what the movie postulates, yes.
Which is funny because I mean, you're only talking about a singular matter, which is weird. You think about just the same matter. I've said two of the same matter can't exist.
Well, what if you have long fingernails and your past self has short fingernails? So
Maybe
the
then, but
extended part of the fingernail, that's different matter, so that would be fine.
that would be different matter. But also talking like you said, you would have to if you really wanted to occupy the say, let's put this yeah, two of the same matter exist in the same space and time at the same time. Like you said, it would really actually have to overlay on each other. Like
Right, exactly. It's because it's like any two humans. Like if you push
yeah,
somebody, your hand doesn't go through them, they go back, so it doesn't really
exactly.
unless there's some kind of strange energy reaction. Because when you're touching the molecules, maybe they can't touch for whatever reason.
Right.
But if that's true, you should still be able to touch their clothes, right?
Should be.
Yeah, I don't know. That's a weird one. Maxwell, any thoughts on that?
No.
All right, so this is the end of the
Wait, but
article.
if it's still the same matter, then if it's if you both wearing the same clothes, then apparently then clearly the clothes can't touch either.
Oh yeah, if you were wearing if yeah, if you had like a favorite shirt or sweatshirt that you both have to wear, yeah, that's true.
That's what it says. The same. It said the same. It didn't say the same person. It said the same matter.
Right.
Wait,
Yeah.
so you're saying like if I time travel into the past and like I see myself, I won't be able to touch my sweatshirt because I'm wearing the same sweatshirt.
Well, your sweatshirts can't touch.
Well,
Why can't they? Why can't they?
this all
Yeah,
hinges on whether or not it really is the same matter.
and matter. Exactly.
Huh.
But for the sake of argument, to be funny about it, say that it is. I would
Well,
really love.
we do have to go back to the basic
Wait,
one.
wait, 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 wait. But why? So this is like kind of like a different theory. Like the same matter can't touch each other. That's what the whole thing was.
That's what the movie Time Cop
Time
said. If
cop.
we're paying attention, Maxwell.
Uh, I never saw the movie. That's pretty cool. Wait, so the
Well,
whole
wrapped up.
movie was like he couldn't like see himself and shit.
You can
Well,
see himself, just not touch himself. Apparently.
then it caused.
So he tries to fight each other and like they couldn't touch each other or like see each other or
Yeah.
what happened?
I think they did fight at all now. They're not fighting still.
So what the hell happened? Did they see
Oh
each
well.
other at all or what?
This whole
Don't
theory of it.
don't ruin the movie, but
All right. All right.
basically you would implode or something. You would implode and and glitch and die because yeah, according to the movie.
Ah, damn! I'm curious now. I haven't seen that movie.
Yeah, check it
Well,
out.
now you have all the reasons to look at it. Yeah.
That's really different from all the
Well,
other time travel movies
it's
I've
the
heard of.
only movie. Yeah, it's the only movie that made that point, which I thought was very interesting. Because in all the time travel research, it seems like that's not like what would really happen if you like punched yourself. You go back in time just to punch yourself in the face. Like, how would that work?
All right.
Ah, damn! Now I'm really curious. Was it any good? Was it good?
Yeah, it's pretty good.
I enjoyed it.
Especially if you like time travel movies. I mean, that's There's not that many high budget, really good time travel movies. You should check it out. But
Pretty
yeah,
cool. It's on my list.
the law of conservation of energy states that energy can neither be created nor destroyed.
Oh,
Okay. So here's the thing though. So matter can have energy. So for example, your body has energy. You have electrons, you have all of this molecular makeup which has energy. Your body's electrical in many ways. The brain, all the different systems are electrical systems. So if matter can't be created and destroyed and it can only be changed from one form to another, what happens when you go back in time and see your past self? Because that would mean that there's extra matter and energy in the universe, but that violates the first law of
yeah.
thermodynamics. So how does that work? That's something else that I always thought about. It's like, how does that work? Or is it a weird transference because of the way that you time travel? So like, does the energy in the black hole or the wormhole or the time machine, if that's negative energy, so according to the theory where it was negative energy or negative matter, some kind of negative energy matter, does that negate the positive, which allows there to be no difference? Because if it's the same negative that you are a positive, is that would that enable the extra matter and energy to exist? Unless you travel to before you exist, because then that problem wouldn't happen because you wouldn't exist there.
Even if you didn't exist, still you'd be extra matter since technically you don't exist. You shouldn't exist in
Well,
this
no, no,
timeline.
no, no, because the timeline that you leave is an empty
Right.
space,
Oh yeah.
right?
Yeah.
So the only way that the problem of
Oh, for the sake of existing in said timeline, you would say, I can see that.
Maxwell.
I missed it. What happened?
Is there anything you don't miss?
So what's
Oh,
quick recap?
by saying that though, if leaving one timeline and acknowledge the fact that okay, you left that timeline, so you left the whole of matter and energy in that, but still within the exact same timeline. You left that particular point in time, but come into the past, you're refilling that space and matter and energy that had disappeared from an earlier time. But with that, which intrigues me, because I'm thinking about it now. Huh. That's wild.
It is, right? Unless, once again, what if these laws of thermodynamics are not the complete laws? So, like, there's infinite undiscovered laws. What if one of the undiscovered laws accounts for that?
True,
Right?
it could.
Yeah, exactly. So, I think that we need to keep that in mind. All right, so that was just the quick intro. So we're about to get comprehensive. So if Maxwell couldn't follow that, he's going to have some serious problems now.
That means all that space within time, future, past, present, and future is an immense amount of energy and matter. Oh,
It is.
infinite, basically.
You know what else is kind of interesting? Like when you really get down to it, and this is quite an aside, like when a new human being is created, how does that work?
Well, remember, it's a conversion of matter and energy.
Which is
Not matter.
essentially, yeah, it's kind of bizarre though. Like once it's in the womb, okay, the baby is using nutrients and blood from the mother, which is so it's taking from there. But what causes that spark at conception that's gonna create a consciousness in DNA? Because even though it's the components of the mother and the father, obviously there needs to be that ignition spark, right? For it
So now, the question is spark of life. That's
exactly,
one.
exactly. Where does that energy come from?
I mean, we have no idea. I mean, spark of life could happen inside the moon on an extremely strong level.
Well, I would be thinking, I would think it would happen at conception, right? Because at the fertilization process is what yields the new DNA.
I got a question. Do you need a heart and mind, though, to develop consciousness? Because in those stages, there isn't one.
Well, unless our definition of consciousness is wrong
That's very true.
or incomplete. If
Could
it's
be one of those.
incomplete, when you have, yeah, it's weird. So, yeah, It's kind of like, do plants? Some people. So do plants have consciousness because they can communicate? They can feel pain.
Dude, that's true.
So when you're kind of dissecting the nature of consciousness itself, just because it doesn't have a heart or a brain, does that mean it doesn't have consciousness? It doesn't have our level of consciousness, but it might have a much lower level of consciousness. Either way, Maxwell, any thoughts? The spark of life. What do you think?
Um, uh, I don't, I don't know,
I wonder what.
cause yeah, I don't know how it relates to time travel, and I think you explained it, but I
It
just don't
doesn't.
get it.
It
So,
does. Well, it doesn't specifically. I
Yeah.
was. It was an aside because if energy can't be created or destroyed, only transferred, even though the genetic makeup of a new human being happens at conception, like what causes the spark? Like you have the sperm and the egg with all the actual data, but what causes the spark to create new DNA, new unique DNA? Like, wouldn't that require extra energy?
hmm.
Yes, many mind shocking things to postulate. All right, let's get back to time travel. So, the Internet Encyclopedia of Philosophy (IEP.UTM.edu) is very interesting. It's a peer reviewed academic resource, and it's basically got a peer reviewed version of Wikipedia to an extent. So, this is their article on time travel, which is quite comprehensive. So, once again, this is Mind Shock. We go deep into all of the topics, so we will be dissecting all of it. Time travel is commonly defined with David Lewis's definition. An object time travels if and only if the difference between its departure and arrival times, as measured in the surrounding world, does not equal the duration of the journey undergone by the object. For example, Jane is a time traveler if she travels away from home in her spaceship for 1 hour, as measured by her own clock on the ship, but travels 2 hours, as measured by the clock back home, assuming both clocks are functioning properly. Before the 20th century, scientists and philosophers rarely investigated time travel, but now it is an exciting and deeply studied topic. There are investigations into travel to the future and travel to the past, although travel to the past is more problematical and receives more attention. There are also investigations of the logical possibility of time travel, the physical possibility of time travel, and the technological practicality of time travel. The most attention is paid to time travel that is consistent with current physical theory, such as Einstein's general theory of relativity. In science, different models of the cosmos and the laws of nature governing the universe imply different possibilities for time travel. So theories about time travel have changed radically as the dominant cosmological theories have evolved from classical Newtonian conceptions to modern relativistic and quantum mechanical conceptions. Philosophers were quick to note some of the implication of the new physics for venerable issues in metaphysics, the nature of time, causation, and personal identity, to name just a few. The subject continues to produce a fruitful cross fertilization of ideas between scientists and philosophers, as theorists in both fields struggle to resolve confounding paradoxes that emerge when time travel is pondered seriously. This article discusses both the scientific and philosophical issues relevant to time travel. You know what's fun to think about, though? What do you think the cosmological worldview or the cosmological view of the universe will be in like another 20, 30, 40, 50, 100 years? It's probably not going to resemble what we have now too much. What do you guys think?
I can agree with that, but my major thing right now is thinking about this. I feel bad for Jane. She lost an hour.
Well, she could get it back, right?
I know, right?
Well, depending on how you travel, but well, everything kind of goes back to hinging on the definition of time.
Very
Because
true.
all of this discussion on time travel without a proper understanding and a real provable definition, because you have physicists saying time's not real, it's just an illusion. You have other physicists saying it is indeed real. And then once again, the other view that we've discussed before, Sid, is the past, present, and future is all happening simultaneously. So it's not necessarily true travel back or forward. It's more like traveling sideways.
Along the circle, yeah.
And
Very,
we will
very
be
that.
getting to that in a dedicated episode, because that is mind-boggling and mind-shocking in its own right, and it will take some time to wrap your brain around that. But Maxwell, did you get that?
No, I didn't.
If time is real, what if it's nonlinear? So that would mean that the past, the present, and the future are all happening simultaneously.
AKA Maxwell. That might explain why you get deja vu sometimes.
That's pretty cool.
Yeah, that's one of the newer. Like, I had only started seeing that recently. Sid actually was familiar with that for a while.
Yeah, yeah. Can't
So
lie.
like everything is now at the same time.
And everything is also in the past, and everything is also in the future.
Yeah.
So it's not. It wouldn't be a linear type of travel. So there's so many different theories out there. But okay, let's get back to this. Introduction. Time travel stories have been a staple of the science fiction genre for the past century. Good science fiction stories often pay homage to the fundamentals of scientific knowledge of the time. Thus, we see time travel stories of the variety typified by H.G. Wells as set within the context of a Newtonian universe, a three-dimensional Euclidean spatial manifold that changes along an inexorable arrow of time. By the early to mid 20th century, time travel stories evolved to take into account the features of an Einsteinian universe, a four-dimensional space-time continuum that curves and in which time has the character of a spatial dimension. That is, there can be local variation or warps. More recently, time travel stories have incorporated features of quantum theory. Phenomena such as superposition and entanglement suggest the possibility of parallel or many universes, many minds, or many histories. Indeed, the sometimes counterintuitive principles and effects of quantum theory have invigorated time travel stories. Bizarre phenomena like negative energy density, the Casimir effect, lend their strangeness to the already odd character of time travel stories. In this article, we make a distinction between time travel stories that might be possible within the canon of known physical laws and those stories that contravene or go beyond known laws. The former type of stories, which we shall call natural time travel, exploit the features or natural topology of space-time regions. Natural time travel tends to severely constrain the activities of a time traveler and entails immense technological challenges. The latter type of stories, which we shall call Wellesian time travel, enable the time traveler more freedom and simplify the technological challenges, but at the expense of the physics. For example, in H.G. Wells's story, the narrator is a time traveler who constructs a machine that transports him through time. The time traveler's journey, as he experiences it, occurs over some non-zero duration of time. Also, the journey is through some different non-zero duration of time in the world. It is the latter condition that distinguishes the natural time travel story from the Wellesian time travel story. Our laws of physics do not allow travel through a non-zero duration of time in the world. In a sense, that will be made clearer below. Wellesian time travel stories are mortgaged on our hope or presumption that more fundamental laws of nature are yet to be discovered beyond the current horizon of scientific knowledge. Isn't that a very logical presumption, since that happens all the time? It's
Oh, yeah, of course.
it's just progress. Natural time travel stories can be analyzed for consistency with known physics, while Wellesian time travel stories can be analyzed for consistency with logic. Finally, time travel stories implicate themselves in a constellation of
Now, I have to say logic within the realm of the story itself,
yes,
if that's the case.
yes.
Understood.
Finally, time travel stories implicate themselves in a constellation of common philosophical problems. Among these philosophically related issues we will address in this article are the metaphysics of time, causality, and personal identity. You know what else is fun to think about? If you believe that everything is destined and there is no real free will, or the whole free will versus determinism debate,
Right.
Does that mean time travel was destined to be invented and a specific time traveler was destined to go back in time?
Inevitability, right? Interesting.
What do you
Let me
think,
see if I have that on.
Maxwell? That was a simple one.
It was.
Maxwell Army. You said you find time travel fascinating, and yet you don't seem fascinated by this discussion.
I am, but I don't get it. Like someone, like,
So
yeah, I don't know
free
what you just
will,
said.
free will versus determinism. If everything is
Yeah,
predetermined, if everything is destined, and there's no real free will, does that mean that a future time traveler was destined to go back in time and change whatever? Which is kind of weird, right? Because, I mean, I don't know, like if
It's predetermined and destined. Why would there be a need for someone to go back
exactly,
in time
exactly,
to alter
yeah,
anything?
right. Unless that was
so that
part of the plan, which again, if we're talking intelligent design of the universe, or some kind of computer code that just runs out and we all have to run the code regardless of what our consciousness was programmed to think that we have free will. If we don't, then why would that have been programmed into the code? Or was the coder just that bored that they added that? It was like an Easter egg. Oh man. What do you think, Maxwell?
it's interesting.
All right, let's go. Okay, two definition. What is time travel? One standard definition is that of David Lewis's an object time travels if the difference between its departure and arrival times in the surrounding world does not equal the duration of the journey undergone by the object. This definition applies to both natural and Wellesian time travel. For example, Jane might be a time traveler if she travels for 1 hour but arrives 2 hours later in the future or 2 hours earlier in the past. In both types of time travel, the times experienced by a time traveler are different from the time undergone by their surrounding world. But what do we mean by the time in time travel? And what do we mean by travel in time travel? As the definition for time travel presently stands, we need to clarify what we mean by the word time. While philosophical analysis of time travel has attended mostly to the difficult issue of time, might there also be vagueness in the word travel? Our use of the word travel implies two places, an origin and a destination. I'm going to Morocco means I'm departing from my original point here and I plan to arrive eventually in Morocco. But when we are speaking of time travel, where exactly does a time traveler go? The time of origin is plain enough. The time of the time traveler and the time traveler's surrounding world coincide at the beginning of the journey. But where does the time traveler arrive? Are we equivocating in our use of the word travel by simply substituting a when for a where? That's a very good point, right? That's not discussed enough. In truth, how do we conceive of a when as a place, a locale, or a region? Different scientific ontologies result in different ideas of what travel through time might be like. Also, different metaphysical concepts of time result in different ideas of what kinds of time travel are possible. It is the issue of time in philosophy that we now turn. 3. Time in philosophy. How is time related to existence? Philosophy offers three primary answers to this metaphysical question: eternalism, possibilism, and presentism. The names of these views indicate the ontological status given to time. The eternalist thinks that time, correctly understood, is a fourth dimension essentially constitutive of reality together with space. All times, past, present, and future, are actual times, just like all points distributed in space are actual points in space. One cannot privilege any one moment in the dimension of time as more real than any other moment, just like one cannot privilege any point in space as more real than any other point. The universe is thus a space-time block, a view that has philosophical roots at least as far back as Parmenides. Everything is one. The appearance of things coming to be and ceasing to be, of time passing or flowing, is simply phenomenal, not real. Objects from the past and future have equal ontological status with present objects. Thus, a presently extinct individual dodo bird exists as equably as a presently existing individual house finch, and the dodo bird and the house finch exist as equably as an individual baby sparrow hatched next Saturday. Whether or not the dodo bird and the baby sparrow are present is irrelevant ontologically. They simply aren't in our space-time region right now. The physicist typically views the relation of time to existence in the way that the eternalist does. The life of an object in the universe can be properly shown as, and they have this graph with an arbitrary now point. So there's curves before and after. So Maxwell, so that's kind of like saying my car is just as real as your car, which is just as real as Sid's car. So we all agree on that in the present moment, right?
Right.
Now here's where it
Okay.
gets tricky. So back in the year 1800, is our future vehicles, are they just as real as the horse carriage that exists at that moment? In this philosophical definition, it would be yes, because it's going to be real at some point in time, therefore it's equally real even if it doesn't exist yet.
Hmm.
Similarly to something that existed in the past that no longer exists, it's set equally as now. Another good way to think about it is geographically. Like New York City is just as real as Los Angeles, even if they're really far away. It just gets tricky, obviously, conceptually, when something before it exists or after it ceases to exist, saying that that is just as real as something that exists right now. What are your thoughts on that, Maxwell?
Um, for some reason, my mind is going towards like manifestation, the nature of manifestation. See, so like anything in the future that is imagined by someone will become. I don't know why it's going to that, but I'm just saying like because you're saying that because, but I don't know what the hell the future holds. I mean, the world could explode or some
All right, well,
shit.
let's
But
use animals like they did. So there was an extinct animal. There's an animal that doesn't exist yet for whatever reason, possibly some kind of if it's a crossbreed that doesn't exist yet of existing animals. It doesn't exist yet. There was an extinct animal, and then there's animals that exist today. Equally? Are all three equal?
yes,
Sid, what do you think?
Very tricky thinking
wait,
about that.
equal just in existence, right?
Yep.
I
I think what Maxwell is saying with the manifestation, it's almost if he thinks about the I think, therefore I am, and if for me thinking and me existing in that fashion, then whatever I must think this also exists. If you want to take it that way, in a funny way. But
What if we remove consciousness? What if we talk about inanimate objects that have existed in the past, no longer exist, or inanimate objects that will exist in the future?
well,
Are they all equal? According to this philosophical definition, all have equal standing.
you could say yes now, and you could also say no, only because the fact that they built this way, unless you have actual proof that which you could believe about said past objects existing, then
Well,
say like I say,
let's talk about unknown objects. So let's get real crazy. Let's get real crazy. So objects that
aka
we
the
don't
five
know.
dollar bill that I left underneath my couch years ago, but then found today. Clearly must have existed back then for me to find today, now, and would exist in the future once I give it to the lady for my burger.
Are we really gonna go to the? If a tree falls in the woods and nobody hears it, are we really gonna go to that?
I'm just saying.
No,
That's
but here,
literally
no,
what
no.
this is.
Let's get real crazy. Let's go into unknown unknowns. So
Alright.
let's talk about objects that we don't even know about that existed in the past, or species of trees that were never even discovered because they're extinct, or whatever. We don't know what that thing is, but
Right.
do things that we don't know that existed, do they have equal standing with things that we don't know will exist in the future? And do both of those have equal standing with things that we actually, or if we're staying consistent, you know how like there's constantly new species of insects and
Oh
all
yeah.
being discovered. So the ones that are undiscovered but are existing in the present moment, we don't know about them. We don't know what they are. Do all of these unknowns have equal status?
They have equal status and a possibility of existing.
No, 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 no. But
Existing in time.
take out the possibility. Like
Yes.
they existed for real before. Even we don't know things that we don't know about really did exist. Just like things we don't know about presently exist, and things we don't know about exist in the future, like really exist. We're not talking about possibilities. We're talking about, since we don't know what they are, we can't say what they are and verify them, but there's definitely things that we don't know about that definitely exist.
And yes,
So we could call them X, Y, Z, whatever. So so you believe they all have equal stat. You agree with this philosophical viewpoint that all have equal standing?
I have to say so, yes.
And Maxwell, you said yes as well?
Yeah.
So
See,
creates an infinite
I'm
conundrum of
biased.
unknown knowledge.
I'm biased. I can't say yes because, not that I'm not saying no either, but the only thing I can really know for sure due to my consciousness is that the present moment is real. That's the only thing I know with certainty because I'm experiencing it. So unless my experience is not real, which I don't know if I would have a way of knowing that. Therefore, the only thing I can really deduce is that it is real because I'm not sure there's a way to prove it's not real.
And because of that, that's why I'm biased and having to say yes, which is similar. But even though I'm exist, I know all my experiences at this point I can define as real. But at the same time, I just can't. Even though we're talking about as if it were real, still a possibility I can't deny.
Oh, I can't deny possibilities, but according to eternalism, they have equal standing, not the possibility of equal standing. Very important distinction. All right, let's move on. This diagram shows the spatial movement in one dimension of an object through time. The standard depiction of an object's space-time world line in special relativity, the Minkowski diagram, privileges this block view of the universe. Many Wellesian time travel stories assume the standpoint of eternalism. For example, in Wells's The Time Machine, the narrator, the time traveler, explains there is no difference between time and any of the three dimensions of space, except that our consciousness moves along it. Eternalism fits easily into the metaphysics of time travel. The second view is possibilism, also known as the growing block or growing universe view. The possibilist thinks that the eternalist's picture of the universe is correct except for the status of the future. The past and present are fixed and actual. The future is only possible. Or more precisely, the future of an object holds the possibility of many different world lines, only one of which will become actual for the object. If eternalism seems overly deterministic, eliminating indeterminacies and human free choice, then possibilism seems to retain some indeterminacy and free choice, at least as far as the future is concerned. For the possibilist, the present takes on a special significance that it does not have for the eternalist. The life of an object, according to possibilism, might be shown as the graph represents the curve for the past and a straight line for the present, and then nothing exists after the present because it's unknown. This diagram shows that the object's world line is not yet fixed or complete. It should be pointed out that the necessity of illustrating the time axis with a beginning and end should not be construed as an implicit claim that time itself has a beginning and end. Some Wellesian time travel stories make use of possibilism. Stories like Back to the Future and Terminator suggest that we can change the outcome of historical events in our world, including our own personal future, through time travel. The many different possible histories of an object introduce other philosophical problems of causation and personal identity, issues that we will consider in greater depth in later sections of the article. The third view is presentism. The presentist thinks that only temporally present objects are real. Whatever is, exists now. The past was, but exists no longer. The future will be, but does not exist yet. Objects are scattered throughout space, but they are not scattered throughout time. Presentists do not think that time is a dimension in the same sense as the three spatial dimensions. They say the block universe view of the eternalists and the intermediate view of the possibilists gets the metaphysics of time wrong. If eternalism has its philosophical roots in Parmenides, then presentism can be understood as having its philosophical roots in Heraclitus. Presently existing things are the only actuality, and only what is now is real. Each now is unique. You cannot step twice into the same river, for fresh waters are ever flowing upon you. The life of an object, according to presentism, might be shown as this. On the graph, there is only a straight line for the present. There is no curve in the past or future. So I'm going to have to take this position because,
It sounds like what you said.
yeah, it makes more sense for me. So the past did happen, but it's not real at the present moment. So the ripples of it might be real as present from the ripples from something that previously existed and no longer exists.
I
Butterfly.
can understand that, yeah.
Maxwell, what do you think? Which view do you take?
Yeah, I got lost in that one.
Really?
Maxwell gets lost on everything. Why are you surprised?
I just thought this was really something that attuned to him. Like, he's really keen on it.
Well, I thought that as well, but for some reason he just doesn't pay attention to any of the actual points being presented. But
Wait, can you summarize it? Like one
Sid,
sentence.
Sid, I got a question for you. Has Maxwell gotten worse or better with his retention since the last time you were on the podcast?
I would love to say the same, but since these presents and past are no longer the same and ever changing, and I have to say maybe slightly better.
Really?
Better.
Wow.
Nah, he's being nice because I'm interested in time travel and shit, and I can't retain shit.
Okay. Many
But he
presentists.
should change the subject of what we're talking about. So
He knows what. Yeah, he's usually pretty good at remembering what the podcast was about, but he's also strayed in that regard as well. There were a couple podcasts where he did forget the subject.
all right,
Maxwell,
so
it's basically the eternalist believes that past, present, and future all have equal standing. A possibilist believes that the past and the present have equal standing, the future does not because it hasn't happened yet. A presentist believes only the present is real. So both the past and the future do not have equal standing with the present. Make sense?
Oh damn, I like the presentist version. but
I get
that's
it.
like kind of like the like yeah, but that's kind of like the spiritual bullshit though. Like
You've been
Eckhart
listening to a
Tolle
lot
and
of
shit.
Eckhart Tolle. The power of now.
Yeah.
Many presentists account for the continuity of time, the time-like connection of one moment to the next moment, by appealing to the present intrinsic properties of the world. To fully describe some of these present intrinsic properties of the world, you need past and future tense truths to supervene on those properties. For example, in ordinary language, we might make the claim that George Washington camped at Valley Forge. This sentence has an implicit claim to a timeless truth. That is, it was true 500 years ago. It was true when it was happening. It is true now, and it will be true next month. Well, hold on a second. That's if that's true.
Exactly.
There's a whole lot of conspiracy theories about George Washington, or there could have been an error in some recording dates. So if it was really 501 or 499 years ago or whatnot, it's not necessarily a timeless truth. But okay. But according to presentism, only presently existing things are real. Thus, the proper way to understand the truth of the sentence is to translate it into a more primitive form, where the tense is captured by an operator. So, in our example, the truth of the sentence supervenes on the present according to the formulation was George Washington camps at Valley Forge. In this way, presentists can describe events in the past and future as truths that supervene on the present. It is the basis for their account of persistence through time in issues like causality and personal identity. The ultimate game of semantics. 4. Time and physics. Since the use of the term time in our definition of time travel remains ambiguous, we may further distinguish external or physical time from personal or inner time. Again, following Lewis. In the ordinary world, external time and one's personal time coincide with one another. In the world of the time traveler, they do not. So, with these two senses of time, we may further clarify time travel to occur when the duration of the journey, according to the personal time of the time traveler, does not equal the duration of the journey in external time. Most, but not all, philosophy of time concerns external time. For the purpose of natural time travel, we need to examine the scientific understanding of external time and how it has changed. A. Newtonian cosmology. Newton argued that space-time and motion were absolute. That is, that the entire universe was a single, uniform, inertial frame, and that time passed equably throughout it according to an eternally fixed, immutable, and inexorable rate, without relation to anything external. Natural time travel in the Newtonian universe is impossible. There are no attributes or topography of space or time that can be exploited for natural time travel stories. Only time travel stories that exceed the bounds of Newtonian physics are possible, and scenarios described by some Wellesian time travel stories, most notably like the ones Wells himself wrote, are examples of such unscientific time travel. Several philosophers and scientists objected to the notion of absolute space-time and motion, most notably Leibniz, Berkeley, and Mach. Mach rejected Newton's implication that there was anything substantive about time. It is utterly beyond our power to measure the changes of things by time. Quite the contrary, time is an abstraction at which we arrive by means of the change of things. This is from The Science of Mechanics, 1883. For Mach, change was more fundamental than the concept of time. We talk about time passing, but what we're really noticing is that things move and change around us. We find it convenient to talk as if there were some underlying flowering substance, like the water of a river, that carries these changes along with it. We abstract time to have a standard measuring tool by which we can quantify change. These views of Mach's were influential for the young Albert Einstein. In 1905, Einstein published his famous paper on special relativity. This theory began the transformation of our understanding of space-time and motion. B. Special relativity. The theory of special relativity has two defining principles: the principle of relativity and the invariance of the speed of light. Briefly, the principle of relativity states that the laws of physics are the same for any inertial observer. An observer is an inertial observer if the observer's trajectory has a constant velocity and therefore is not under the influence of any force. The second principle is the invariance of the speed of light. All inertial observers measure the speed, c, of light in a vacuum as 3 by 10 to the 8th power meters per second, regardless of their velocities relative to one another. This principle was implied in Maxwell's equations of electromagnetism, 1873, and the constancy of c was verified by the Michelson-Morley interferometer experiment, 1887. There's a whole bunch of conflicting information about the Michelson-Morley experiment. But anyway, we won't get into that here. This second principle profoundly affected the model of the cosmos. The constancy of c was inconsistent with Newtonian physics. The invariance of the speed of light according to special relativity replaces the invariance of time and distance in the Newtonian universe. Intervals of space, like length, and intervals of time, and hence motion, are no longer absolute quantities. Instead of speaking of an object in a particular position independently of a particular time, we now speak of an event in which position and time are inseparable. We can relate two events with a new quantity, the space-time interval. For any pair of events, the space-time interval is an absolute quantity, that is, has the same value for all inertial observers. To visualize this new quantity, one constructs space-time diagrams, Minkowski diagrams, in which an event is defined by its spatial position, usually restricted to one dimension, x, and its time, ct. Thus, a space-time interval might be null, parallel to the trajectory of light, which, because of the y-axis units, is shown at a 45-degree angle. Space-like, little or no variation in time, or time-like, little or no variation in spatial position. The following figure shows a Minkowski diagram depicting the flat spacetime of special relativity and 3 different spacetime intervals, or world lines. What are the consequences of special relativity for time travel? First, we lose the common sense meaning of simultaneity. For example, the same event happens at two different times if one observer's initial frame is stationary relative to another observer's initial frame moving at some velocity. Furthermore, an observer in the stationary inertial frame may determine two events to have happened simultaneously, but an observer in the second moving inertial frame would see the same two events happening at different times. Thus, there is no universal or absolute external time. We can only speak of external time within one's own frame of reference. The lack of simultaneity across frames of reference means that we might experience the phenomenon of time dilation. If your frame of reference is moving at some fraction of the speed of light, your external time passes more slowly than the external time in a frame of reference that is stationary relative to yours. If we imagine that someone in the stationary frame of reference could peek at a clock in your frame of reference, they would see your clock run very slowly. So in special relativity, we can find a kind of natural time travel. An example of special relativity time travel is of an astronaut who travels some distance in the universe at a velocity near the speed of light. The astronaut's personal time elapses at the same rate it always has. He travels to his destination and then returns home to find that external time has passed there quite differently. Everyone he knew has aged more than he, or perhaps has even been dead for hundreds or thousands of years. Such stories are physically consistent with the Einsteinian universe of special relativity, but of course they remain technologically beyond our present capability. Nevertheless, they are an example of a natural time travel story adhering to the known laws of physics, which do not require exemptions to fundamental scientific principles, for example, the invariant and inviolable speed of light. But as a time travel story, they require that the time traveler also be an ordinary traveler too. That is, that he travels some distance through space at extraordinary speeds. Furthermore, this sort of natural time traveler can only time travel into the future. Conversely, from the perspective of those in the originating frame of reference, when the astronaut returns, they witness the effects of time travel to the past, perhaps, because they have a person present among them who is alive in their distant past. So natural time travel, according to special relativity, is perhaps too limited for what we normally mean by time travel, since it requires considerable spatial travel in order to work. In addition, there are other limitations, not least of which is mass-energy equivalence. This principle was published by Einstein in his second paper of 1905 entitled, "Does the Inertia of a Body Depend Upon Its Energy Content?" Mass energy equivalence was implied by certain consequences of special relativity. Other theorists later discovered that it was suggested by Maxwell's electromagnetism theory. Mass energy equivalence is expressed by the famous formula E equals mc squared. It means that there is an energy equivalent to the mass of a particle at rest. When we harmonize mass energy equivalence with the conservation law of energy, we find that if a mass ceases to exist, its equivalent amount of energy must appear in some form. Mass is interchangeable with energy. Now only mass-less objects, like photons, can actually move at the speed of light. See that? Does nobody remember tachyons? Tachyons move faster than the speed of light, and not to mention, Tesla already debunked all of this way back when, on top of run Z cow.
Can you explain what a tachyon again?
Okay, so according to all of these, I guess it'd be kind of extreme to call relativity fraud, but some people believe that's what it is. According to the relativity fraud, you can't travel, no particles would travel faster than the speed of light. But tachyons were discovered quite some time ago. So a tachyon or a tachyonic particle is a hypothetical particle that always travels faster than light. Most physicists believe that faster than light particles cannot exist because they are not consistent with the known laws of physics. If such particles did exist, they could be used to build a tachyonic antitelephone and send signals faster than light, which, according to special relativity, would lead to violations of causality. This is from Wikipedia. It's saying that no experimental evidence for the existence of such particles has been found, but they have been found.
I'll tell you right now, though, all those people who love to watch The Flash, they all know about it. Their obsessions. Boy.
But anyway, yeah, it's kind of funny how
That's pretty cool. Tachyons and shit. That's like Star Trek shit.
well, physics, it's kind of funny because physics for the past 100 years, ever since the so-called fraud of relativity was brought upon the field of physics, where it was kind of taken as Einstein's self-admitted house of cards was taken as gospel truth and the foundation upon everything which was built. So it's the propaganda campaign to maintain status quo is pretty strong. So they can't, so it's kind of hard to even find, like, you have to dig pretty deep. Like, for example, they had supposedly announced, oh, they found gravitational waves, thus proving relativity. Well, if you dig deep and read the actual papers, this was injected data. So this was admittedly falsified data, which they've done multiple times. I mean, they've done this multiple times now. This isn't the first time. For years and years, they've claimed to discover gravitational waves, and yet the data was admittedly injected as a test without telling the scientists carrying out the experiments. So that's just many examples in which the so-called fraud of relativity, the propaganda spins to maintain this fraud. Once again, I urge everybody to check out Run Z Cow's work, because he explains it quite simply. And there's, of course, been much more complicated debunkings of relativity, but this particular article on time travel, they bought into the propaganda. They're stating that relativity is kind of like the gospel truth of the laws of physics, as opposed to just theories. But let's move on. See general relativity. In special relativity, all inertial frames are equivalent. And while this is a useful approximation, it does not yet suggest how inertial frames are to be explained. Mach had stated that the distribution of matter determines space and time. But how? This was the question answered by Einstein in his theory of general relativity in 1916. Special relativity is actually a subset of general relativity. General relativity takes into account accelerating frame of reference, that is, non-inertial frames, and thus the phenomenon of gravity. The topography of spacetime is created by the distribution of mass. Spacetime is dynamic, it curves, and matter tells a region of spacetime how to curve. Likewise, the resultant geometry of a space-time region determines the motion of matter in it. The fundamental principle in general relativity is the equivalence principle, which states that gravity and acceleration are two names designated the same phenomena. If you are accelerating upwards at a rate g in an elevator located in a region of spacetime without a gravitational field, the force you would feel and the motion of objects in the elevator with you would be indistinguishable from an elevator that is stationary with a downward uniform gravitational field of magnitude g. To be more precise, there is no force of gravity. When we observe astronauts who are in orbit over the Earth, it is not true to say that they are in an environment with no gravity. Rather, they are in free fall within the Earth's gravitational field. They are in a local inertial frame and thus do not feel the weight of their own mass. One curious effect of general relativity is that light bends when it travels near objects. This may seem strange when we remember that light has no mass. How can light be affected by gravity? Light always travels in straight lines. Light bends because the geometry of spacetime is non-Euclidean in the vicinity of any mass. The curved path of light around a massive body is only apparent. It is simply traveling a geodesic straight line. If we draw the path of an airplane traveling the shortest international route in only 2 dimensions, like on a flat map, the path appears curved. However, because the Earth itself is curved and not flat, cue the conspiracy theorists, the shortest distance, a straight line, must always follow a geodesic path. Light travels along the straight path through the various contours of spacetime. Another curious effect of general relativity is that gravity affects time. Imagine a uniformly accelerating frame, like a rocket during an engine burn. General relativity predicts that depending on one's location in the rocket, one will measure time differently. To an observer at the bottom or back of the rocket, depending on how you want to visualize its motion, a clock at the top or front of the rocket will appear to run faster. According to the principle of equivalence, then, a clock at sea level on Earth runs a little slower than a clock at the top of Mount Everest because the strength of the field is weaker the further you are from the center of mass. The other strange thing about all these is if this can be explained by other means, then if relativity really is bunk, and this is all explained by other means, then again, all of this is built on a house of cards. So Maxwell, to answer your question from before, a lot of the differences with Tesla and Einstein hinge on things like ether or the electromagnetic universe as opposed to gravitational mass based universe. So Tesla believed in the ether, the medium which theoretically is existing all around us, and that's the medium through which everything would move or exist. So the Michelson-Morley experiment, there's different interpretations of that experiment and what it really proved. Some people allege that the results were fraudulent. I've read the actual results. It does appear to have been falsified with the intent to disprove ether for whatever reason. But if you look back throughout all the history books and the physics books, ether was once accepted as fact, and even ancient civilizations mention ether in one form or another. Tesla believed in ether, and a lot of his free energy theories and practicalities and actual experiments and inventions worked. So that's the other point. Tesla had hundreds of inventions that were proven to work. Einstein had zero. He had a bunch of theories based on assumptions taken as gospel truth, whereas Tesla had practical evidence. Again, he might be wrong, but he has hundreds and hundreds of inventions that work within his model. So that's a lot more substantive body of evidence than Einstein had, because Einstein had nothing to prove his theories, whereas Tesla had hundreds and hundreds and hundreds of examples and inventions that prove his theories. Again, they could both be wrong. The real truth could be theory C. We don't know. But does that answer your question from before, Maxwell?
Yeah, that's sufficient.
Okay. Are natural time travel stories possible in general relativity? Yes, they are, and some of them are quite curious. While most of space-time seems to be flat or gently rolling contours, physicists are aware of space-time regions with unusual and severe topologies such as rotating black holes. Black holes are entities that remain from the complete collapse of stars. Black holes are the triumph of gravity over all other forces and are predicted by a solution to Einstein's general relativity equations, written by Kerr in 1963. Once again, these are all just theories stated as facts. When they rotate, the singularity of the black hole creates a ring or torus, which might be traversable, unlike the static black hole, whose singularity would be an impenetrable point. If an intrepid astronaut were to position himself near the horizon of the rapidly spinning center of a black hole without falling into its center and possibly being annihilated, he would be treated to a most remarkable form of time travel. In a brief period of his personal time, he would witness an immensely long time span in the universe beyond the black hole horizon. His space-time region would be so far removed from the external time of the surrounding cosmos that he conceivably could witness thousands, millions, or billions of years elapse. This is a kind of natural time travel. However, it severely restricts the activity of the astronaut time traveler, and he is limited to travel into the future. Are there solutions to general relativity that allow natural time travel into the past? Yes, but unlike rotating black holes, they remain only theoretical possibilities. Einstein's neighbor in Princeton, Kurt Gödel, developed one such solution. In 1949, Gödel discovered that some world lines in closed spacetime could curve so severely that they curve back onto themselves, forming a loop in spacetime. These loops are known as closed time-like curve, CTCs. If you were an object on a CTC world line, you would eventually arrive at the same spacetime position from which you started. That is, your older self would appear at one of its own earlier spacetime points. Gödel's CTC spacetime describes a rotating universe. Thus, it is an extreme case for a CTC because it is globally intrinsic to the structure of the universe. It is not considered a realistic solution since current cosmological theory states that the universe is expanding, not rotating. One type of space-time region that a natural time traveler might exploit is a wormhole. Two black holes whose throats are linked by a tunnel. Wormholes would connect two regions of space and two regions of time as well. Physicist Kip Thorne speculated that if one could trap one of the black holes that comprise the mouths of the wormhole, it would be conceivable to transport it, preferably at speeds near the speed of light. The moving black hole would age more slowly than the stationary black hole at the other end of the wormhole because of time dilation. Eventually, the two black holes would become unsynchronized and exist in different external times. The natural time traveler could then enter the stationary black hole and emerge from the wormhole some years earlier than when he departed. Unfortunately for our time traveler, if wormholes exist naturally, many scientists think they are probably quite unstable, particularly if quantum effects are taken into account. So any natural wormhole would require augmentation from exotic phenomena like negative energy in order to be useful as a time machine. Another type of CTC suggested by Gott, 1991, employs two infinitely long and very fast-moving cosmic strings of extremely dense material. The atom with strings would have to travel parallel to one another in opposite directions. As they rushed past one another, they would create severely curved spacetime, such that spacetime curved back on itself. The natural time traveler would be prepared to exploit these conditions at just the right moment and fly his spaceship around the two strings. If executed properly, he would return to his starting point in space, but at an earlier time. One common feature of all CTCs, whether it is the global Gödelian rotating universe or the local regions of rolled up spacetime around a wormhole or cosmic strings, is that they are solutions to general relativity that would describe CTCs as already built into the universe. The natural time traveler would have to seek out these structures through ordinary travel and then exploit them. So far, we are not aware of any solution to general relativity that describes the evolution of a CTC in a space-time region where time travel had not been possible previously. However, it is usually assumed that there are such solutions to these equations. These solutions would entail particular physical constraints. One constraint would be the creation of a singularity in a finite region of space-time. To enter the region where time travel might be possible, one would have to cross the Cauchy horizon, the hourglass-shaped, for two crossing cosmic strings, boundary of the singularity in which the laws of physics are unknown. Were such a CTC constructed, a second constraint would limit the external time that would be accessible to the time traveler. You could not travel to a time prior to the inception date of the CTC. Natural time travel, according to general relativity, faces daunting technological challenges, especially if you want to have some control over the trajectory of your world line. One problem already mentioned is that of stability, but equally imposing is the problem of energy. Fantastic amounts of exotic matter, or structures and conditions similar to the early moments of the Big Bang, like membranes with negative tension boundary layers, or gravitational vacuum polarization, would be needed to construct and manage a usable wormhole. Infinitely long tubes of hyperdense matter would be needed for cosmic strings. Despite these technological challenges, it should be pointed out that the possibility of natural time travel into the past is consistent with general relativity. But Hawking and other physicists recognize another problem with actual time travel into the past along CTCs: maintaining a physically consistent history within causal loops. One advantage of some interpretations of relativistic quantum theory is that the logical requirement for a consistent history in a time travel story is seemingly avoided by postulating alternate histories or worlds instead of one history of the universe. D. Quantum interpretations. Certain aspects of quantum theory are relevant to time travel, in particular the field of quantum gravity. The fundamental forces of nature, strong nuclear force, electromagnetic force, weak nuclear force, and gravitation, have relativistic quantum descriptions. However, attempts to incorporate gravity in quantum theory have been unsuccessful to date. On the current standard model of the atom, all forces are carried by virtual particles called gauge bosons, corresponding to the order given above for the forces: mesons and gluons, photons, massive W and Z particles, and the hypothetical graviton. A physicist might say that the photon carries electromagnetic force between real particles. The graviton, which has eluded attempts to detect it, carries gravity. This particle characterization of gravity in quantum theory is very different from Einstein's geometrical characterization in general relativity. Reconciling these two descriptions is a robust area of research, and many hope that gravity can be understood in the same way as the other fundamental forces. This might eventually lead to the formulation of a theory of everything. I'm going to have to do another quick aside here because, once again, when we talk about this so-called Einsteinian fraud or the house of cards, all of these theories are built on that. So if the principles of the base layer of the house of cards are false, then everything above it would not necessarily be false, but if it's true for other reasons than they think that it's true. For example, Tesla was actually going to unveil a thermodynamic theory of gravity, and this is based on an electromagnetic universe. So according to Tesla, gravity didn't work anything like what Einstein thought it did or why he thought it did. Does that make sense?
Yeah, I can see that.
Maxwell?
Yeah, I got lost there.
Were you lost from the opening moment of the podcast?
I don't know. Can you review it real quick? I might have a response.
Okay. If Einsteinian physics is all fraud, if it's a house of cards, the base layer is false, everything above it is false. So all of these other things, like the postulation of a graviton, all of these other theories built on his theories, any of it that's true might be true for reasons completely different than they think it's true. So when they measure something, they might think it's because of XYZ in Einsteinian physics, when it's really because of ABC in something completely different. For example, Nikola Tesla was actually going to unveil a thermodynamic theory of gravity, which he actually never got to do. He alluded to it, but then he died, or depending on which conspiracy theory you believe in, he might have been killed, even though he was very old. But he was going to unveil his thermodynamic theory of gravity, which might explain the universe much better. Once again, he had hundreds of inventions that actually worked. So instead of all this just theorizing on top of theorizing, I mean, this is all basically just guesses justified by math, but you can use math to justify anything. Math is based on certain axioms. It doesn't necessarily prove anything. It's just a tool that can be used to prove or disprove, but the truth remains the truth. So my point with all of this theorization is that simply if the base layer is wrong, if gravity doesn't work the way they think it does, there's so much out there, especially now with the internet, you can find even from 100 years ago, a lot of different theories, some of which logically make a lot more sense than relativity. Once again, if you check out Run Zikow's work, you'll see the debunking of all of this, time dilation, basically all of the points of relativity, he dismantles quite thoroughly and simply. So if none of that's true, what are we left with? We're left with a whole bunch of other possibilities and unknowns. That was my only point. What do you think about that?
That was a very interesting analysis.
Because if gravity doesn't work the way they think it works, so like they're postulating all these things based on gravity working the way that it does in general relativity, it's all bunk if it's based on bunk. So, okay, continuing on, scientists have proposed several interpretations of quantum theory. The central issue in interpretation of quantum theory is entanglement. When two quantum systems enter into the temporary physical interaction, mutually influencing one another through known forces, and then separate, the two systems cannot be described again in the same way as when they were first brought together. Microstate and macrostate entanglement occurs when an observer measures some physical property, like spin, with some instrumentation. The rule, according to the orthodox or Copenhagen interpretation, is that when observed, the state vector, the equation describing the entangled system, reduces or jumps from a state of superposition to one of the actually observed states. But what happens when an entangled state collapses? The orthodox interpretation states that we don't know. All we can say about it is to describe the observed effects, which is what the wave equation or state vector does. Other interpretations claim that the state vector does not collapse at all. Instead, some no-collapse interpretations claim that all possible outcomes of the superposition of states become real outcomes in one way or another. In the many worlds version of this interpretation, Everett, 1957, at each such event, the universe that involves the entangled state exfoliates into identical copies of the universe, save for the values of the properties included in the formerly entangled state vector. Thus, at any given moment of collapse, there exist two or more nearly identical universes, mutually unobservable yet equally real, that then each divide further as more and more entangled events evolve. On this view, it is conceivable that you were both born and not born, depending on which world we're referring to. Indeed, the meaning of world becomes problematic. The many universes are collectively designated as the multiverse. There are other variations on the many worlds interpretation, including the many minds version, Albert and Lauer, 1988, and the many histories versions, Gell-Mann and Hartle, 1989. However, they all share the same central claim that the state vector does not collapse. Many natural time travel stories make use of these many world conceptions. Some scientists and storytellers speculate that if we were able to travel through a wormhole, that we would not be traversing a space-time interval in our own universe, but instead we would be hopping from our universe to an alternative universe. A natural time traveler in a many worlds universe would, upon their return trip, enter a different world history. This possibility has become quite common in Wellesian time travel stories, for example, in Back to the Future and Terminator. These types of stories suggest that through time travel, we can change the outcome of historical events in our world. The idea that the history of the universe can be changed is why many of the inconsistencies with causation and personal identity arise. We now turn to these topics to examine the philosophical implications of time travel stories. 5. Causation. Inconsistencies and incoherence in time travel stories often result from spurious applications of causation. Causation describes the connected continuity of events that change. The nature of this relation between events, for example, whether it is objective or subjective, is a subject of debate in philosophy. But for our purposes, we need only notice that events generally appear to have causes. The distinction made between external and personal time is crucial now for the difficulties of causation in some time travel stories. Imagine Heloise is a time traveler who travels 80 years in the past to visit Harold. They have a fight and Heloise knocks out one of Harold's teeth. If we follow the progression of Heloise's personal time or of Harold's, the story is consistent. Indeed, time travel seems to have little effect upon the events described. The difficulty arises when we test the consistency of the story in external time, because it involves an earlier event being affected by a later event. The ordinary forward progress of events related to Harold 80 years ago requires a schism in the connectivity and continuity of those events to allow the entry of a later event, namely Heloise's time travel journey. The activity of Heloise is causally continuous with respect to her personal time, but not with respect to external time. Assuming that the continuity of her personal identity is not in question, as we shall discuss in the next section. With respect to external time, this story describes reversed causation. For later events produce changes in earlier events. How does the story change if Heloise is homicidal and encounters her own grandfather 80 years ago? This is a scenario many think show that time travel into the past is inconsistent and thus impossible. Once again, that's the grandfather paradox. So, I just had a major thought that I just completely forgot. I'm turning into Maxwell. She
Maxwell?
travels into the past and has a fight with herself. Or she has a fight with somebody else. And the butterfly effect. Okay. I got it. Okay, so check this out. So you know how so we could link this to deja vu or the Mandela effect or some of these other wackiness. So what if someone traveled back in time, did something that they didn't think would affect something, and it caused some kind of a butterfly effect ripple? So the deja vu is your memory of something that happened before a time traveler changed something. Does that make sense? So maybe because of the butterfly effect,
Oh, I see.
because of the butterfly effect, the ripples. So it could have been something completely innocuous. A time traveler went back in time and got a winning lot, like okay, maybe not innocuous, maybe got a winning lottery ticket, whatever, for somebody else. It caused something. This could be on the other side of the world. But
Right, right.
somehow that person did something else, that did something else, that did something else that affected even, let's say, a chain of restaurants existing. So you have deja vu from a certain building with a certain layout that's similar, but it doesn't exist in your current timeline or didn't. Because before a butterfly effect caused by time travel caused certain ripples, your previous memory was prior to the butterfly effect time traveler.
I have seen that before used in certain media, so yeah, I understand that.
Maxwell, what do you think about that?
Um. No, I don't know.
So
Maxwell
it's it.
Powers is an integral part of the MindShock podcast. Like, I don't know how would we even function or do a podcast without Maxwell's input.
So, um, yeah, I don't know. I don't know what the point was. Like, yeah, I don't know.
So you're familiar with the butterfly effect, right?
Yeah, something happens here and then fucking it causes tidal waves on the other side and shit.
So let's say, so your deja vu could have been caused by the butterfly effect of a time traveler. So if the person hadn't time traveled, it wouldn't have caused these ripples that somehow affected where you were or what you did. So your
Huh.
deja vu is your brain sort of glitching because the butterfly effect caused reality to be different. But if it wasn't for the time traveler, it would have been another way. So that's your deja vu.
Wait, like another different version of deja vu or no deja vu?
Sid Irwin, do you understand his question?
Like you're
I think
saying,
I
let's say
do.
you're saying if it wasn't for a time traveler, you would not have deja vu
Correct.
or okay.
That particular, because if the time traveler didn't cause a butterfly effect ripple, your deja vu wouldn't be deja vu because reality would have played out differently in the timeline if not for the butterfly effect.
Funny you put it that way, 'cause I thought it'd be more a different. When you said different deja vu, I got in the sense where, okay, you feel deja vu because you feel like you're doing a certain aspect again,
Even
right?
if
A
you
certain
hadn't done
action,
it before, right? But what if you
right?
had done it before prior to a time traveler causing a butterfly effect?
Well, with Wi-Fi effect, I'm saying in the sense that does that directly mean that you will end up still like it doesn't affect you in the sense that you're still going to end up doing the same action, or would you be doing the
Well,
same
no,
action, or
because
do a different action?
if there was no time traveler, you would have performed the action and it wouldn't be deja vu.
Oh, okay, I see what you're
It
saying.
would just be a regular memory.
Oh
Right. Yeah.
shit! I finally got it, dude. That shit's
Finally,
awesome.
we're mind shocking Maxwell. But isn't that crazy to think about?
That's fucking awesome.
Yeah, I just came up with that right now. It's just
Wait. That's your shit.
yeah, I just came up with that right now.
That's awesome.
Well, all the memories that you have that
That's a movie.
yeah. Maxwell's got a weird obsession with movies. I brought this up before, Sid, but I actually asked Maxwell why he even bothers watching movies because he's not going to remember what was in the movie anyway. All right, let's move
Yeah.
on to causal loops. So, a causal loop is a chain of causes that closes back in on itself. A causes B, which causes C, which causes X, which causes A, which causes B, and so on ad infinitum. This sequence of events is exploited in some natural and Wellesian time travel stories. It is a point of debate whether all time travel stories involving time travel to the past include causal loops. As we have seen, causal loops can occur when extraordinary cosmic structures curve space-time in a negative direction. Wellesian time travel stories with causal loops describe scenarios like the following one by Keller and Nelson, 2001. Jennifer, a young teenager, is visited by an old woman who materializes in her bedroom. The old woman describes intimate details that only Jennifer would know and thus convinces Jennifer to pursue a professional tennis career. Jennifer does exactly as the old woman suggested and eventually retires, successful and happy. One day, she comes into the possession of a time machine and decides to use it to travel back in time so that she might try to make her teenage years happier.
Jennifer travels back into the past and stands before a person she recognizes as her younger self. Jennifer begins to talk to the teenager about hidden talents and the bright future before her as a tennis professional. At the end of their conversation, Jennifer activates the time machine and returns to her original timeline. We can describe the causal loop in Keller and Nelson's story as follows. The story contained within the causal loop is presented on the left side. At event C, the story splits with the causal loop continuing along C1 and the exit from the loop beginning at C2. At C2, the world line of Jennifer occurs outside the causal loop events. Thus, A, Jennifer is visited in her bedroom by teenage Jennifer is visited in her bedroom by old Jennifer. B, teenage and old Jennifer talk about tennis. C1, teenage Jennifer says goodbye. C2, old Jennifer says goodbye. D1, teenage Jennifer matures and has a successful tennis career. D2, old Jennifer returns to her original timeline. E, Jennifer obtains a time machine. F, Jennifer uses the time machine to travel back in time. A, Jennifer, the teenager, is visited in her bedroom by old Jennifer. B, ad infinitum. So the events of Jennifer's life include a causal loop. Some of those events have no beginning and no end. What is the problem with the story? Each moment of the causal sequence is explicable in terms of the prior events. But where or when did the crucial information that Jennifer would have a successful tennis career come from originally? While each part of the causal sequence makes sense, the causal loop as a whole is surprising because it includes information ex nihilo. It is controversial whether such uncaused causes are possible. Some philosophers, for example, Meller, 1998, think that causal loop time travel stories are impossible because causal loops are themselves impossible. They argue that time and causality must progress in the same direction. Other philosophers, for example, Horwich, 1987, argue that while causal loops are not impossible, they are highly implausible, and thus space-time does not permit time travel into the local past, like one's own life, because fantastic amounts of energy would be required. Still, other philosophers, for example, Lewis, think that causal loops are possible because at least some events, like the Big Bang, appear to be events without causes, introducing information ex nihilo. Which, by the way, Maxwell and I have discussed this like ad nauseum. The Big Bang violates, obviously, the laws of thermodynamics because energy cannot be created or destroyed. So, how could something come from nothing? And then how could animals and humans come from a rock? Like, where's all that extra energy? Any thoughts on that, Sid?
That mentioned, I mean, I agree with that wholeheartedly. As and everyone's had to as you think about it by that perspective, so that I'm not even gonna get into that's a whole other discussion exactly as to how the universe existed then, or how should I say consciousness developed to recognize that universe.
Yeah, that's another one. Yeah, that's bizarre. But anyway, so if causal loops,
But I get that. That always has been one of the bigger issues with causal loops is just the question of how it began, or the cause it to be even to exist like that, and then go on and so on and so forth.
Okay, so
Yeah.
according to Hawking, causal loop stories that employ CTCs are like grandfather paradox stories. While backwards causation might be logically possible, it is not physically possible. The Chronology Protection Agency actively prevents them from occurring. The laws of physics conspire such that natural time travel into the past thwarts backwards or reverse causation. In closed space-time, the Cauchy horizon of a CTC acts as an impenetrable barrier to a time-like world line for objects. If a time traveler could travel to the past, whether or not that past included their younger self, they are prevented from interacting with the events of the past. If causal loops are possible, then the objects may interact with the events of the past, but only in a consistent way. That is, only in a way that preserves the already established events of the past. Perhaps we could call it the CTC prime directive. See Ray Bradbury's short story, A Sound of Thunder. Causal loops, like any other aporia of uncaused causes, occupy the inexplicable perimeter of philosophical thought about causation. Nevertheless, causal loop stories like that of Jennifer raises another issue: personal identity. 6, personal identity. The old Jennifer travels back in time to talk with her younger self. Are there two Jennifers or just one Jennifer? At event A. At the same moment in external time, a young Jennifer and an old Jennifer are separated by a distance of a few feet. At that moment, is there one person or two? Identity theory involves the relationships between the mind and the body that attempts to show the connection between mental states and physical states. It tries, for example, to describe and explain the connection, if any, between mind and the brain. For Lewis, the mental-physical distinction is crucial for explaining how a time traveler like Jennifer is one person, even when she travels back to talk with her younger self. Our cognitions change according to the requirement of causal continuity. These mental states occur in personal time. For everyday purposes, we can ignore the distinction between personal time and external time. Personal time and external time coincide. But for a time traveler like Jennifer, identity is maintained only by virtue of the traveler's personal time. Their mental states continue like anyone else's. And at any given point in personal time, later mental states do not cause earlier ones. In the case of Jennifer, it is therefore proper to say that at event A in her life, there is only one person, even though it is also true to say from an external perspective that she has two different bodies present at event A. Is that mind-boggling or what? Is it two different consciousnesses, or is it one with two different bodies and two different brains?
Huh. That is interesting.
Yeah, this is definitely the least looked at aspect, I think, of time travel. I've definitely spent the least amount of time on this. Because can your consciousness exist simultaneously? Obviously, it's two different bodies with two different
Right.
brains. But technically, I suppose it would be two different consciousnesses because each of them is experiencing reality. They're conscious of reality.
I would have to think so. Well, at least let's put it this way. At least the media would consider itself, from what I've seen, like different movies or shows where they've had the same characters, like who from different timelines exist in the same, relative timeline, but
You want to,
neither's consciousness becomes aware of the other.
yeah,
Although may
you want to get real
um,
crazy? Do they have two different souls or one, or is there only one soul?
that's a good question. I wonder about that too. But I feel like if you
Maxwell's an expert in souls. What do you think?
Um, uh, yeah, it's kind of messed up.
That's all you got?
Well, it, well, the nature of souls, I really don't understand either. I mean, like, I don't know, I don't even know if I believe in souls. So, like, so a double soul, like, based on the soul theory. Um, I don't know. That's that's interesting to think about, though. Make a good movie alongside with the other one.
Lewis's distinction between the sense in which you can and the sense in which you can't has its coda in the subject of personal identity. In the sense of personal time, Jennifer is one person who is perceiving another person from either Jennifer's perspective. The older Jennifer's materialization into the presence of the younger Jennifer is strange, to be sure, but in a time travel story, it is explicable. I think this might actually hold the key to understanding time travel, actually. I'm just thinking now, looking at all this, if is your consciousness linked to your specific timeline? So, in certain fields of philosophy, especially some New Age theories and some ancient civilizations, their belief systems, some of them believe that all reality is personally created for you. So, if we're going ancient Hindu, in the Hindu model of the universe, God is the collective consciousness of every single person on earth. So we're all the same entity. So God is just experiencing reality in different consciousnesses, but there's one source, and that's what God is. So when you experience your life, you're experiencing your personal reality for your personal consciousness. Does that make sense?
I get that theory set up. I usually hear it more when people apply it to like the afterlife for themselves.
Well, if we want to get real crazy, who's to say this existence isn't the afterlife?
I can't lie, I've thought that quite a few times myself.
If there's multiple layers of reality in different realms, so like again, the Hindu system has it's pretty interesting. We'll definitely be doing some dedicated podcasts on that. But the fact that thousands of years ago they already had this model, I mean, it incorporated some quantum physics. It incorporates a lot of these advanced physics models thousands of years ago. But the point is, if reality is made specifically for each consciousness, that would mean that your version of you has their own reality. So at any given point in time, that's your reality. So young Jennifer, that's her particular consciousness linked to her timeline. Whereas the old Jennifer who time travels, her timeline, her reality is her personal timeline. And that would mean when she's going back in time, that's her version of reality. So that means the reality or the world line is linked to a specific consciousness, and that they're two different consciousnesses. And is that the key to understanding all of time travel? So it's almost like it doesn't matter if you time travel or if you don't time travel. Either way, your reality is linked to your consciousness. Maxwell, thoughts on that?
I got nothing.
Me and Sid are so shocked at that. I mean, I'm just shocked and appalled. Usually you have so much to offer the conversation.
Okay, can you repeat the question again?
I'm just saying, if all of reality, your experiencing of reality, is linked to your consciousness, so someone else's reality is linked to their consciousness. So I mean, there's an old Native American quote I remember reading somewhere that wake up, the Creator has made a new day for you. So that would mean like all of the mountains and hills and animals and people were all made specifically just for you in your unique life and your unique experience to your consciousness. So everybody has their own unique reality that they experience. So if you time travel, that's your unique reality, which would mean it's linked to your consciousness. So your timeline and reality is linked to your consciousness, whether or not you time travel. That's what I just said before. So it's almost like there is no objective reality for everybody. It's like everyone has their own unique reality, which is true to their consciousness.
Huh.
Maxwell, you don't get it?
So my reality is like based as is unique to my own, or some shit like that.
All right, let's finish this up. Maxwell's fading fast.
Lewis's distinction between the sense in which you can and the sense in which you can't has its coda in the subject of personal identity. In the sense of personal time, Jennifer is one person who is perceiving another person from either Jennifer's perspective. The older Jennifer materializes into the presence of the younger Jennifer is strange to be sure, but in a time travel story, it is explicable. Regardless, in her personal time, the causal continuity of her perception and thus mental states is consistent. In the sense of external time, from the perspective of their surrounding world, there are two Jennifers at event A. The mental state of younger Jennifer is not identical to the mental state of older Jennifer. But those mental states, these stages of Jennifer's life, are not duplicates of the same stage. Rather, two moments of personal time overlap at one moment of external time. So is it still proper to say that there are two of her? Lewis argues no, it is not. In the strange case of a time traveler like Jennifer, her stages are scattered in such a way that they do not connect in a continuously forward direction through external time, but they do connect continuously forward through her personal time. The time traveler who meets up with her younger self gives the appearance to an outside observer that she is two different people, but in reality, there is only one person. The question of how objects persist through time is the subject of the endurance and perdurance debate in philosophy. An endurantist is someone who thinks that objects are wholly present at each moment of an interval of time. A perdurantist is someone who thinks that objects only have a temporal part present at each moment of an interval of time. The perdurantist claims that the identity of the whole object is identified as the sum of these temporal parts over the lifetime of the object. It seems that it is impossible for an endurantist to believe the story about Jennifer because she would have to be wholly present in two different spatial locations at the same time. We're going time cop again.
Yes, sir.
The endurantist can avoid this problem by appealing to the distinction between personal time and external time. If Jennifer is wholly present at different locations at the same time, which kind of time do we mean? We mean external time. The endurantist can claim that two different temporal stages in her personal time just so happen to coincide because she's a time traveler at different locations at a single moment of external time. For those of us who are not time travelers, our different temporal stages are also distinct moments in external time. But in either case, whether time traveler or not, a person is wholly present at any moment of their personal time. The perdurantist seems to have an easier way with the problem of personal identity in time travel stories. Since a person is only partially present at each moment of external time, it is readily conceivable that different temporal parts might coincide, but we still need to appeal to the distinction between personal time and external time. The two temporal parts of Jennifer's life that occur when the young and old Jennifer meet and have a conversation are each elements among many others that in toto form the whole person. Personal identity is especially problematic in many worlds hypotheses. Consider the case of Heloise and her desire to murder her grandfather. According to the many worlds hypothesis, she travels back in time, but by doing so, also skips into another universe. Heloise is free to kill her grandfather because she would not be killing her grandfather. That is the same grandfather that she knew about before her time travel journey. Indeed, Heloise herself may have split into two different persons. Whatever she does after she travels into the past would be consistent with the history of the alternative universe.
Yeah.
What?
Oh no, I'm agreeing with that part. I'm here.
But
Listening.
but the question of
But
who exactly Heloise or her grandfather is becomes problematic, especially if we assume that her actions in the different universes are physically distinct. Is Heloise the sum of her appearances in the many worlds, or is each appearance of Heloise a unique person? But to that point, we didn't really discuss that specifically. When you go back in time to kill your grandfather, that's not your grandfather.
that's very true because yeah.
So that paradox doesn't exactly apply either. Man, time travel is rough, right, Maxwell?
And again, that's if you kill your grandfather before he has his own children, at least it's them having you.
But
Yes, yes.
either way, whether he does or he doesn't, in both scenarios, that
Oh
still
yeah,
should not be
technically,
your grandfather.
into a different. If you're brought to a different universe, then yeah, technically that isn't your grandfather.
Now, why is it that again? These are really rough brain teasers. But why? Let's say there are infinite universes in the multiverse.
Mm-hmm.
Why is it impossible to travel back in time in your own to where it would really be your grandfather?
Good question.
Now, like, let's say there are infinite universes, multiverse theory, many worlds theory, whatever. Let's say that's true. Who's to say you can't travel back in your own as well as in others?
Well, it's probably if there's infinite universes, and I just imagine it, a universe like that does exist.
And here's another thing going to the causal loops where in the Jennifer scenarios. So if we have free will, so let's say Jennifer goes back in time, old Jennifer goes back, she tells teenage Jennifer to become a tennis pro. Okay. When tennis pro Jennifer grows up to be an old woman, she has the option, let's say, because if she develops a time machine, or in that universe, in that new timeline, if she became a tennis player, maybe she would never have developed a time machine or been exposed to one. So she would never have the option to become an old Jennifer that travels back in time.
All right.
Maxwell, you following?
So
AK, what he's saying.
some tennis player pro can't go back in time or some shit.
What he's saying is that it was her older self that went back in time to encourage her to become a tennis pro. But you have
So
to question.
old Jennifer
was
Right.
never a tennis pro for whatever reason. She abandoned that dream and she had a different
Oh,
life.
okay.
So old Jennifer so she wants a better, so somehow because of the life that she had, maybe she went into science instead and was dead broke, but managed to develop a time machine, however it worked, or meet some people that developed a time machine. So she was able to go back in time and tell young Jennifer to become a tennis player. So young Jennifer became a tennis player, thus having a different life, and maybe never developing a time machine or encountering people that developed one because her life was so different, becoming a tennis pro. So in that causal loop, there is no paradox because the old Jennifer, the old tennis player Jennifer, never goes back in time because she lived the life that the non-tennis player old Jennifer, the original, helped her live.
Exactly. Because the cause is eliminated.
Wait,
Without
so
Right.
going
so
back
wait,
in
so
time.
so wait, so the scientist Jennifer just fucking deletes itself.
No, she existed, but the future self doesn't ever go back in time because now there is no original because she became a tennis player. So both existed in the past, but presently there is no she doesn't go back to visit young Jennifer. Again, it was a one-time thing. It's not an infinite loop. Although the point I was going to make is if there's a little bit of determinism involved, or if time travel technology just becomes available at some point, whatever, like let's say it's her sister or her brother that develops it. So even if she's a tennis pro, she would still have access to it. Let's say she still has access to it when she becomes old Jennifer. Now she has the option to go back in time for whatever reason, but she became the tennis pro. So there's no real reason unless she was unhappy with her life as a tennis pro and goes back in time and recommends Jennifer become a scientist instead. Or thus living the original Jennifer's timeline, restoring order to the universe. You know what's crazy? Like, let's say that happened infinite time. If we're in a one world timeline, if there's only a single universe, a single timeline, maybe that's happened infinite times where some kind of time traveler wants to make life better for themselves, but it actually makes it worse. Thus, the loop is not a real loop, but it's a restoration cycle.
Oh.
Because there is one timeline that's kind of meant to happen through determinism. What do you think about that, Maxwell?
Um, it's it's not making sense because I don't know. I don't understand. I don't understand what you mean by restoration, like loop thing.
I just explained it.
It just
If
it's
Jennifer
not clicking in because
Jennifer
the scientist would not be a scientist if
No,
he turns pro and shit.
forget the scientist. Old Jennifer lived X life and wasn't happy with it. So she goes back to tell teenage Jennifer to live Y life. So teenage Jennifer grows up, lives the Y life, but she's not happy with it. So she goes back in time again and tells teenage Jennifer to not live the Y life. So she actually lives the original X life, which maybe is better.
So are you saying that the Y never happened and it turns into X instead?
It restores to the original timeline. Because if the original timeline is determined to be the true timeline that's meant to be, no matter how many time travelers happen, it'll always restore to the original meant to be timeline.
It's
It sounds like fucking that Tom Cruise movie and shit with the fucking the aliens and time travel
Oh
thing.
yeah. I'm not sure you're talking about.
Edge of Tomorrow?
Yeah.
Yeah.
Yeah, that's a pretty good movie. I mean, it's not really because you're not waking up you're not reliving the same day all the time. It's actually quite nothing like that. But
It's actually quite nothing like
Maxwell, what are you
Um,
smoking?
wait, I don't know. It's like this restoring thing is fucking me up and shit.
How do you not get it? Jennifer A.
Well,
goes back in time.
I like.
now what intrigues me is this,
Well, I.
since you have
Is it
Jennifer
what you're saying is that no matter
Jennifer
what
A.
happens, it has to restore itself, which I don't know. It's just fucking
Jennifer
weird.
A wasn't happy with her life. So she told Jennifer B, the teenage Jennifer, to be a tennis player instead because she thought that would make her happy. But Jennifer B grows up being a tennis player and she's actually not that happy. So she goes in time and tells Jennifer C not to be a tennis player. So Jennifer C grows up living Jennifer A's life.
How does that not make sense?
Okay, so he turns into a fucking scientist instead of a fucking tennis player.
Forget
Actor,
scientist and
scientist.
tennis player.
Just,
Jennifer C lives Jennifer A's life. Jennifer A wanted Jennifer B to have a better life, but it actually wasn't better. So Jennifer B went back in time to tell Jennifer C. These are all the same person, but this is the third. This is
So it's like, are these three different timelines because
yes.
like three different universes?
No, this is all the same universe.
So, but so
Okay.
is that different from timelines as you're referring to?
Your question has nothing to do with what I'm saying.
This is
Okay.
my question. My observation makes it interesting. Wouldn't that cause a causal loop?
No, because well, it
Because I mean,
depends. It
because
depends.
there's a chance if Jennifer C doesn't like living
But if she
A's
does,
lifestyle
if
like
she,
she did before, she might end up going back in time and then redoing this.
maybe, and that was my point. The option
Yeah.
is this. So Jennifer, for example, Jennifer B, if she was happy with her life, she would never go to Jennifer C. But if Jennifer C might have lived Jennifer A's life, but because a time traveler told her to, she thought that was the better life, so she doesn't go back and change it and make a Jennifer D to live Jennifer B's life.
Remember, if that's the logic used, Jennifer A came back to tell Jennifer B not to live said life because this one has the potential to be better.
Correct, but if she was wrong, you know what I'm saying? If she was wrong and Jennifer B didn't like it, therefore Jennifer C would live Jennifer A's life. And at that point, Jennifer C, if she was happy, then the loop is closed and she's done. If Jennifer C is not happy, then a Jennifer D occurs. But
Alright,
that's not a guarantee.
as long as we're on the same page in that fashion, I'm good.
Yeah, so a lot of things to ponder. It seems Maxwell's still lost.
Yeah, I gave up on the C.
At least you got B. That's good.
Oh man. All right. Well, we got plenty more time travel episodes coming up where we're going to explore a lot more in the problems and explanations for different theories of time travel. And we will also be getting into actual time machines that were built and actual alleged time travelers with varying degrees of evidence in future podcasts. So we hope you enjoyed another edition of the MindShock podcast. If you like our podcast, you can donate to our PayPal. Just check the link in the description. Make sure you subscribe to the channel. Hit the bell for notifications. And if you like the video, hit the like button. Feel free to share it across social media platforms. Any questions, comments, criticisms, praise, or insults to either of us or Maxwell, feel free to leave that in the comments as well. And also make sure to like our Facebook page, and you can check us out on Reddit, Twitter, and Patreon as well. This is Bruce McGuire signing off.
And Maxwell Powers.
And Sid Aaron wishing you farewell.
We'll see you guys next time.
If you like audiobooks or audio shows, check out a free trial of Audible. Just click the link in the description.
You are listening to MindShock. This is your host, Bruce McGuire.
And Maxwell Powers.
And Sid Irwin.
And we are back for Time Travel Part 2. The Paradoxes of Time Travel. If you haven't checked out Time Travel Part 1, The Nature of Time Travel, check that out. It is probably the most comprehensive overview of time travel in existence on the interwebs. Would you guys agree?
So far.
I'm not sure.
What have you seen that was better, Maxwell? Come on, man. Do you think there's nobody out there with a better memory, better recall, better articulation than Maxwell Powers?
Well, I'm not sure if I ever heard a time travel podcast just really specializing in that topic. So
Yeah, MindShock is a pioneer of many topics. So once again, if you like the podcast, you can donate to our PayPal. Just check the link in the description. Make sure you subscribe to the channel, hit the bell for notifications. If you like the video, hit the like button. Feel free to share it across social media platforms. Any questions, comments, theories, thoughts of any kind, just drop them in the comment section. And you could also check us out on Twitter, Reddit, Patreon, and make sure to like our Facebook page as well. Okay, so Maxwell, I'm sure you said you really like time travel movies, so this is a favorite topic of yours. You just didn't seem to pay too close attention on the first podcast, but are you kind of all caught up now on the mechanics or the different theories of how the mechanics of time travel could work?
I I don't remember, but I don't remember the technicalities. The technicalities like really.
We went over the classic grandfather paradox of how if you go
Oh
back in time period,
yeah.
yeah. So we'll be going into a few different paradoxes, and we'll be getting into the specifics of different paradoxes. And of course, Sid Irwin, the former Mensa member, who won't tell us what happened with Mensa. Did they kick you out, or did you just like stop going? Like, what was the deal? What's the deal, Sid?
As far as I can tell, with my fellow Mensa compatriots, we just didn't see eye to eye.
Are you saying your IQ was too high for them and they were just jealous and that caused problems?
No, just that my IQ was too high for them, and it just felt like they were just wasting my time and holding me back. So felt I needed to move on. That's all.
Oh, okay. All right. Well, I'm sure you'll be in
He's
good company with Maxwell Powers.
he's Sid Irwin's quite modest.
Yes, indeed.
I
All
am.
right.
Thank you.
So this is actually an article from Frisian.com, which is very, very interesting. It opens with a quote from Revelation 10:5-6 or 10:5-6. I'm sure Maxwell knows his Bible passages. You got it, Maxwell?
Nah, I got nothing, man. I got
And,
nothing on the Bible verse.
and the angel swore that time will be no more. It's kind of ominous, isn't it?
Wait, what the hell does that mean?
Well, the angel is saying that there will be no more time.
Could be a matter of perspective. It could be ominous in the sense of potentially, if you think as if it's the end of all time, that means it might be the end of all existence. Or it could be the end of all time, and things might have just simply frozen in place from there on. Or just that without time, certain things are no longer affected.
What
They
if
may not
time,
age.
what if time is some kind of an artificial construct by the intelligent designer or designers or software program of the universe that can be turned on or off? Kind of like anti-aliasing in a video game.
Or definitely start. If it's funny you mentioned video games, now I can think about is Star Ocean till the end of time, which
I'm not familiar with that one.
well, essentially the plot ended up being exactly what you just described.
Wow, that's awesome.
No,
I gotta say, I gotta have a new catchphrase. Like that would make a good video game to to kind of
Copy Maxwell Powers.
yeah, to kind of yeah. Maxwell's got his that would make a good movie. I should start. That would make a good video game. So basically, they just switched it off, kind of like real time physics or something in a video game.
that would be awesome. I mean,
So this is how it goes. Robert Heinlein's 1941 story, By His Bootstraps, begins with the narrator writing in a philosophy thesis that time travel is impossible because time, in Immanuel Kant's terms, is only empirically real and does not exist independently among things in themselves. The narrator is then suddenly surprised to find two different versions of himself arriving from the future with conflicting warnings and promises about what he can do. Traveling to the future, he meets an older man who repeats the promises but whom he ends up distrusting. After some confusion, back in the present, he obtains some supplies and returns to the future to a period significantly earlier when he would met the older man, intending to contest the future with him. Eventually, however, it turns out that he himself is the older man, and his future is in fact pace Immanuel Kant secured.
A paradox of time travel arises in relation to this story. The narrator does indeed set himself up by his bootstraps. His present and future selves all interact with each other to produce the events. The paradoxical nature of this comes down to the case of a notebook that was provided to the narrator by the older man in the future. It contained a vocabulary of the language that was spoken by people in the future. The narrator learns the language and, as the book wears out over the years, copies it over into a notebook he had fetched from the present. This notebook, as it happens, is the very one he, as the older man, then provides to his other self. He is therefore the same person who learns the knowledge from the notebook and put the knowledge into the notebook in the first place. The vocabulary is a certain list of items arranged in a certain way, was thus compiled by no one whatsoever. The knowledge exists in a closed temporal loop and is in important sense uncaused or uncreated. The narrator himself notes that there is something peculiar about this. Peculiar indeed, a very similar paradox, allowed by the possibility of the same kind of temporal loop, can become a reductio ad absurdum for time travel. We see such a paradox in the 1980 movie Somewhere in Time, starring Christopher Reeve and Jane Seymour. Are those your favorite actors, Maxwell?
But wait, Christopher Reeve, you said?
And Jane Seymour, yes.
James Seymour.
Dr.
I
Quinn,
forgot who that
medicine,
is.
Dr. Quinn, medicine woman.
Oh, yeah. I read about her, but like she was like House in the Prairie lady, right? Son.
Little House on the Prairie?
I don't know. I think that's where the Dr. Seymour or whatever it was that she played.
Okay.
Wait, what?
I don't know what I'm talking about. I don't know who the hell she is, but she's like, I just remember a photo of her. I think she's pretty. She's really pretty, long hair and shit. And I just remember her with holding a freaking basket on top of it, like a hill and a fucking like a cabin. That's all I remember.
I remember some guy throwing axes. That's all I remember about that one. All right, so have you guys seen that movie, by the way? Somewhere in Time?
I have not, but it sounds interesting, and I might put that on my list.
Yeah, you like time
Did I?
travel movies. I haven't seen it. Sid, have you seen it?
Yeah, put on a.
No, I have not.
As a young man, Reeve encounters an old woman who gives him a watch. Later, he becomes obsessed with the painting of a woman in an old 19th century hotel, actually filmed in the beautiful Mackinac Island in Michigan. He decides that he must meet that woman, and he thinks it is possible because of the theory of a professor he had for physics. The professor thinks that it is possible to will oneself back in time as long as what one carries along is not anachronistic for that time. I haven't heard that one before. Have you heard that one before, Maxwell? Sid, that you could just go back in time if you feel like it?
I have to look up anachronistic. I don't know. Is that like
Not fitting to the
Yeah.
time period. Like, so if you bring your iPhone back to the Wild West, for some reason it won't work, according to this professor in this movie. So if you're wearing clothes for the time period and you don't bring anything that conflicts, apparently your willpower alone is enough to do that. Have you heard about this this type of time?
That's pretty cool. So I can be
Oh.
like, so I only have something here, a book from the past. I think it was published in 1936. So I can hold it, but I have to be butt naked because like everything can't be from the present or future. So
What year was?
well, not from the future. 1936.
Why
I
don't
think
you
it
just
was.
why don't you just wear like a suit?
That's funny.
Sid, have you ever heard of this theory? You could just will yourself
No.
back in time?
No, I've never heard of it. Though I do remember one show called The Misfits where the person did have the ability to transport his consciousness back in time. That's about as far as I can go.
When you say consciousness, so not his body?
Not his body, just his
Oh, that's pretty
consciousness
cool.
into his previous body at a different point in time. Actually,
Wow, that's
both
pretty
both
interesting. I haven't heard of that. I've heard of remote viewing going back in time, but not your consciousness actually inhabiting another body as a vessel. That's pretty interesting.
both forward and backwards.
I didn't know remote viewing can go back in time. I
Well,
don't know
there's
if
a whole
we
bunch
ever
of
talked
different.
about this, but
There's a subset of remote viewing. You could basically view any event, past, present, or future.
okay, huh? No kidding.
Yeah. Well, this isn't quite exactly time travel. That's more of a remote
So
viewing
no,
topic.
that makes that's kind of cool too, because like I was thinking like I don't know, doing some remote viewing exercise with Maura Murray or something.
Yeah,
I'm gonna solve that case with
there's
my
actually
remote viewing skills.
there's actually quite a few people already working on the remote viewings with some. We're gonna actually do a remote viewing podcast on the Moore Murray case as well.
Oh, sweet.
Yeah. All right.
I'm gonna be doing remote viewing while we're doing
All right. Cool. So you'll be able to
it.
contribute. You'll be able to contribute to the actual remote viewing. Okay. Reeve, so in the movie, Reeve outfits himself for the 19th century and actually succeeds in willing himself back into it. He meets the woman in the picture, played by Jane Seymour, and he is able to win her heart so that she returns the love he felt ever since seeing her painting. He gives her the watch that he had acquired many years before from the old woman. Then, as their mutual happiness seems assured, Reeve discovers a penny from the 20th century in his suit, and the anachronism vaults him back into the present. He is unable to endure separation from his beloved, starves himself to death in his hotel room, and apparently is reunited with her in the hereafter. All right, this doesn't make any sense at all. I'm not sure I even want to watch this movie now because hold on a second. If you're unaware of the anachronism, it doesn't count. So if you leave your iPhone in your back pocket and you forget it's there, you can travel back in time, but as soon as you become aware of it, you go back to the present. But then why doesn't he just will himself back in time without any anachronism? Or is this a one-shot deal? Is this every human only gets one chance to go back in time? And if they do it without being anachronistic, then it's all okay and they can stay back in time? This doesn't make any sense. Sid, does this make any sense to you?
Yeah,
Well, to me, from what I can tell, just guys have seen some other things talk about time travel in a sense where actually even what the Flash, that's what I was watching. They had spoke that well, I guess in one theory said that you could travel back in time and that there's only certain key points in time that matter, while there are other smaller subsequent points that are irrelevant to honestly affect the timelines, so it eventually just smooths itself back out. So as long as, I guess, yes, if you do no anachronistic events, like let's say, instead of JFK getting killed, you end up saving him, then yeah, things should be fine.
Yeah, but if you bring something, according to this movie, you can't bring anything with you that's anachronistic.
It is anachronistic, and you shouldn't be able to bring anything with you,
But
especially
he brought a penny but he didn't discover it. So only when he became aware of the penny was he vaulted back into the present. Does that make any sense at all?
that doesn't make any sense. It's very
Not to
odd.
mention, and then he starves himself to death in his hotel room. Why doesn't he just will himself back in time again to see her?
Huh,
That
that
I
is
don't know.
very odd.
I'm not sure I want to watch the movie now. But anyway, okay. So the old woman who gave him the watch in his youth was, of course, Jane Seymour's character. Lived to a ripe old age just to see him again. The watch, therefore, was obtained by Reeve from Seymour, and was obtained by Seymour from Reeve. In a closed temporal loop, like the knowledge in the notebook in Heinlein's story, the watch is uncreated. But this is impossible. The watch is an impossible object. It violates the second law of thermodynamics, the law of entropy. If time travel makes that watch possible, then time travel itself is impossible. The watch indeed must be absolutely identical to itself in the 19th and 20th centuries, since Reeve carries it with him from the future instantaneously into the past and bestows it on Seymour. The watch, however, cannot be identical to itself, since all the years in which it is in the possession of Seymour and then Reeve, it will wear in the normal manner. Its entropy will increase. The watch carried back by Reeve will be more worn than the watch that would have been acquired by Seymour. The reductio ad absurdum created by the watch can be fixed in a couple of ways. First, we might think that entropy could be reversed by time travel, so that forms of matter would be restored to the state that they would have been at the earliest period. But this will not do, since Reeve himself would then be restored to the state his manner was in the 19th century, which, whatever it was, would not be in the form of Christopher Reeve. Second, we might think that time travel puts one in an alternate universe. In some universe, the watch is manufactured and bought in the ordinary way, and the older Jane Seymour, for whatever reason, gives it to the young Christopher Reeve. He goes back in time to an alternative universe where Seymour did not acquire an unmanufactured watch and gives her his. Then she gives it to him later, and he returns to a different universe where Seymour does not buy a watch, but acquires a somewhat more worn watch from him. The temporal loop thus generates a spiral of alternative universes. Unfortunately, it would require a spiral of an infinite number of alternate universes, as each watch in a particular universe is returned to a new universe where it can exist in its increasingly worn state. In some universe, the watch would disintegrate while in Seymour's or Reeve's keeping and need to be discarded. But Reeve would keep returning to the past unless the watch turned out to be some causal factor in his falling in love with the picture. What do you guys think?
That's one
Yeah.
impressive watch.
Maxwell, did you follow all that?
No.
It's very simple. If he gives her the watch when he travels back in time, and then the older Jane Seymour gives him the watch when he's young, the watch should be in different states of wear, like wear and tear, just from existing, being carried around, oxidation, whatever. So it
Oh,
can't.
okay.
So it can't be the same, right? So it's kind of like that's paradoxical. That's what I just went over.
I see.
Which would be true.
So what do you think? Does
Wait,
that
wait a second. So wait, hold on a second. Hold on. Let me get this straight. So all right. So Christopher Reeve got this freaking watch from an old woman, right? When he was an adult, right?
no? When he
And
was
then when
when he was young.
So like 10. Okay, so like he was 10 or some shit like that. He grabs a watch and then he travels to the future, or like what happened? Or did he grow
Well,
up and
he
then go
lives
back?
his life. No, he lives his life. Years pass. Then he travels back and gives her the watch.
Why would she give it back? Why would he give it back?
Wait,
Why would he give it back? I don't get it.
wait. What do you mean?
Okay, so he was a young kid. He got a watch, and then he grows up, and he's holding this watch, and then he travels back in time to give her back the watch.
Well, he just gives her the watch. It doesn't really matter why. Like he gives her like a souvenir, a gift, whatever. I haven't seen the movie. Maybe she knows. Well, I don't know what it's irrelevant. Why he gives her the watch is completely irrelevant to everything we're talking about. Because there's X amount of years of wear and tear on the watch. He gives her the watch, then he gets booted back to his present because he had an extra he had a penny that was anachronistic. So Jane Seymour, whatever, as an older woman, she gives the young version of Reeve that same watch. Okay, why the motivations of anybody giving anybody a watch is completely irrelevant to the whole point of this. Do you not see how it's irrelevant?
So what's the point? Your point is the deterioration of the watch
Yeah.
should be.
Does that make
Should
time
be-
travel impossible if the watch is in the same state at all times? Because the watch did not have more wear and tear, therefore it's paradoxical. It's always it's exactly the same during the transference.
Yeah, that's messed up. It's like inconsistent with.
Paradox, yes.
Yeah.
Or the entire theory behind how this whole movie is supposed to be based off is entirely wrong, and the watch itself is a time traveling device.
Ah, I like that. You should be a screenwriter, Sid.
I tried.
Huh. That would make sense, wouldn't it? You know, it would be weird if, because we don't know the exact years here, if since he gave her the watch, did she use the watch? I mean, I don't know the exact years because it says as a young man she gives him the watch. So there seems to be a lot off with that movie. But anyway, let's focus on the paradoxes. Every instance of time travel generating an infinite number of alternate universes might be thought to violate Occam's razor, especially since the idea that an alternate universe could be generated in the first place has disturbing consequences for the metaphysics of identity. What does it mean if there are an infinite number of each of the characters all facing a universe slightly different? Simplicity and common sense rebel against such principles. Although serious versions of such metaphysics have been produced to deal with quantum mechanics, and multiple real universes were proposed by the philosopher David Lewis to explain possibility and necessity, after Sal Kripke used Leibniz's idea of possible universes to produce a quantified version of modal logic. But without them, time travel that would allow for the sort of temporal loop in which the paradoxical and impossible watch of somewhere in time becomes possible is itself impossible. While the notebook of By His Bootstraps and the watch of Somewhere in Time produces paradoxes for the concept of time travel, nothing is as simple or stark as the grandfather paradox. Thus, you go back in time and murder your grandfather, take your choice, before he has any children. Thus, one of your parents never would have been born, and then you would have never been born. But if you had never been born, then you would not exist to go back in time and murder your grandfather. The possible murderer of your grandfather is removed from existence by the very act of murder, an act that now cannot happen. But then, if it doesn't happen, you do exist and you can go back in time and murder your grandfather. This begins to sound like the liar paradox, where if a sentence is true, it's false, and if it's false, it's true. You neither can nor cannot murder your grandfather. So the liar paradox, which is, let's go over that real quick. So the statement, this sentence is false. If that sentence is false, then what it says is true. Therefore, it is true. Maxwell, did you follow that?
No, not really.
This sentence is false. Repeat that, Maxwell.
This sentence is false.
Okay. If what you just said is false, then what it says is true, right? Therefore, it is true.
Yeah.
But how could it be true? If
Um,
you just said this sentence is false, so if you're lying about
well,
that,
your claim to it being false is inaccurate.
no. Let's say, for the sake of argument, that you're lying. Let's say you're lying. You're trying to lie to me, and you're saying this sentence is false, trying to trick me.
It's still true because it's apart from what you're saying.
Okay,
don't get
if the sentence is true, then what it says is false. Therefore, it is false. So this was actually introduced and debated in Hellenistic philosophy, and at least one person has committed suicide because of this liar paradox, because of thinking about it.
Is that factual, or did he?
Yes,
Is that
no,
like
that's
it's like a tale?
no. There's a footnote here about
What's the dude's name that killed himself? Got to be some kind of like language that we use his name to refer to this type of behavior. His name is probably suicide or some shit.
So you're saying maybe he defined as the first suicide in all existence.
Or suicida or some shit like that.
I don't think so. But
Or Swissida or some shit.
do you get Sid, are you following this? This sentence is false. So what happens if you're lying to me? If you're trying to lie to me and say the sentence is false?
I'll tell you, it's true.
But if it's true, then what
irrelevant.
it
It's irrelevant if you're like it's irrelevant if you're lying or not. Like what you say is a sentence.
All right, forget about motivations and lying. If let's say you think it's true, but it's actually false, like we're discussing two possibilities. The sentence could either be true or it could be false, right? So if it's true, like we could swap it out for 1 + 1 is 2, 1 + 1 is 5. It doesn't matter what
But
it is.
but anything you say as a sentence, whether the content is projecting to be false, is irrelevant because it's a sentence.
Now, let's think about it as an equation. Like you say, 1 + 1 is 2, 1 + 1 is 5. One of them is true, one of them is false. We could discuss if it's true or if it's false. We're doing that with this sentence. This sentence is false. Let's discuss the sentence. Either it's true or it's false, right? So if the sentence is false, then what it says is true. Therefore, it is true.
I just look at it as a true sentence. That's all I see. I don't know what the other ones are.
So 1 + 1 is 5 is a true equation. I mean, it's not. It's not accurate. We're talking about if I say you're wearing whatever, you're wearing a blue shirt, you're actually wearing a red shirt. Okay, there's a truth. It's a sentence. You're wearing a blue shirt. But if it's actually red, then it's a non-true sentence, right? I think you're missing the whole point here, Maxwell. The content of this, you're focusing on the fact that it's an actual sentence. Yes, of course, but that's not the point of any of this. The point is the content is true or false. So let's say it's true, then what it says is false. Therefore, it's false. That's the whole paradox. I don't know if Sid, can you think of a way to explain this to Maxwell?
Uh, I just went back in time and murdered myself, and now I'm having a conversation with you.
Now I'm even more confused.
Wait, so that like if Sid gives that example, that means he will travel in time sometime in the future since he's talking with us or something.
Oh man. Oh
Because
man.
he's gonna go back in time and kills himself. So he kills himself as his age today, but like somewhere like 15 minutes from now, he travels back in time to kill himself.
Okay, hold on a second. Let's okay, there's a little explanation here. So the peculiarity of the liar paradox, if we switch its assertion from false to true, the contradictions generated by the paradox disappear. But we are left with a further question. Okay, we might think if it's true, and if it's false. That is the case with any non paradoxical proposition. If it's raining today, it's raining. If it's not raining, it's not raining. Big deal. But then we are left to wonder, is the anti liar true? Or is it false? How do we determine that? Well, ordinarily, we look to the cognitive ground of the proposition. To know it if it is raining, we look out the window. But both the liar and anti liar statements only refer to themselves. Therefore, if they are either true or false, there must be something about them that makes them true or false. We find lots of things like that in logic where the sentences that cannot be false are tautologies, and where the sentences that cannot be true are contradictions. This bothered Hellenistic Stoics because of the principle of the excluded middle, which is that propositions are either true or false. It doesn't look like the liar can be either true or false since each one even implies the other, which just drove them bananas. However, notice that without generating any contradictions, we have the same problem with the anti-liar. How can it be either true or false? If it is self-referential, which means that its truth can only be determined by its own form or meaning, but the form or proposition can determine its own truth or falsehood only if it is either a tautology or a contradiction. Neither the liar nor the anti-liar is either a tautology or a contradiction, and the content of the proposition is simply to refer to itself. The anti-liar, as much as the liar, violates the principle of the excluded middle, so it is actually the anti-liar that exposes the issue without the distractions of the contradictions generated by the liar. So the problem is with that. Indeed, there is nothing internally or externally, form or meaning, that provides a ground for truth of the anti-liar. It is though we are given a proposition, P, and asked whether it is true or false. Well, we can't say, and our objections will be that we cannot determine truth or falsehood without knowing its meaning. Logicians say an interpretation. But its meaning is merely self-reference with nothing else. In a sense, this means that P consists of nothing but P with a predication of truth, i.e. TP, just as the liar is a predication of falsehood, i.e. FP. That is not much help, but a predication of truth can be added or removed as well. So strictly speaking, P remains without meaning. It has no semantic content beyond a redundant logical form, and it is no more paradoxical than any other misinterpreted P, such as is used in logical symbolism all the time. In fact, since Aristotle. So our answer to both paradoxes may be that they actually have no meaning, and so cannot have a true value, unless we have a three-value logic that adds unknown or undetermined to truth and false. That does indeed violate the excluded middle, but then it may be necessary, for instance, in quantum mechanics. It is also, in fact, the practice of logic where uninterpreted symbols like P are used. Unless they are tautologies or contradictions, their truth value is undetermined until interpreted. So that's actually a very interesting point if you were following Maxwell. We have an unknown quantity, an unknown entity, or an unknown law at play. So if the watch can remain in perfect condition, is it due to some kind of energy that has to do with time travel that we simply don't know about?
I see.
It's an interesting take.
An unknown variable. So anyway, back to what this guy was saying, you can or cannot murder your grandfather. We discussed that as well, where if it exists, we went pretty deep in that in the previous episode. You can check that out. We solved that a few different ways, but this could be fixed up again with multiple universes. You don't just travel in time, you are leaving the universe in which you exist and enter a universe where your actions mean that you will not exist. No problem. The original universe is not altered. However, this does mean that there actually is not true time travel. There is only travel between alternate universes where you can enter the alternative universe at a random point in time. Does this falsify the premise? I expect so, but the simpler move is then to forget the alternative universes and just deny that there can be time travel. The paradox is resolved without all the paradoxes inherent in the theory of multiple universes itself. Each of these paradoxes involve a kind of loop in time. The knowledge in By His Bootstraps circulates from past to future and back without having an actual causal origin external to the loop. There is something peculiar about that, but it doesn't seem to violate any logic or laws of nature. The watch in Somewhere in Time, similarly, is uncreated, but it does violate the laws of nature. For its existence through time on the loop involves wear that will not be undone by its transport from the future to the past. Once again, do we know that for sure? If there's infinite undiscovered laws of physics that are somehow affected or negated by time travel, then that could explain it. Anyway, the watch at the point of transfer in the future cannot be the same watch at the point of arrival in the past, since the watch in the past becomes the watch in the future through many years of operation of entropy. In the grandfather paradox, the problem with the loop in time becomes more acute. The violation moves from being one of the laws of nature into the realm of actual logic, albeit the logic of the basic nature of causality. Thus, the third noble truth of Buddhism is that you remove the effect by removing the cause. Removing the grandfather thus removes the effect, namely the murderer himself. Here we have not a continuity along the loop of the linguistic knowledge of the watch, but a discontinuity. The causal chain is broken rather than continued. This is why we get a phenomena similar to the liar paradox. The existence of the murderer makes the murder possible, but the murder makes the murderer and the murder impossible. With Occam's razor, the simplest fix is the denial of time travel. Kant's theory of time may go unrefuted after all. And once again, we have Occam's razor being applied at least somewhat inaccurately, because once again, it states that if both explanations adequately explain, the simpler one should be used, and there's virtually no scenarios where two different theories perfectly equally explain something. So if the more complex theory explains it better, that should be used once again. And then, of course, I went over actually in our Bigfoot Skeptics podcast, we went over Occam's razor as well pretty extensively. For those that haven't checked that episode out, check that out, because Occam's razor, nature doesn't even work along Occam's razor because nature is just incredibly complex. So anyway, that's a brief outline of some of those paradoxes. I'll do a quick rundown from astronomytrek.com on 5 bizarre paradoxes of time travel. One quick point about what I just read, though. I don't think we discussed this before. If it's all true and there's a single timeline, did we talk about this in the previous episode? If it's all true and you do go back in time, murder your grandfather, that all happened. You really did go back in time, and then now neither one of you exists, and the single universe timeline continues.
We did talk about that.
What? Did we talk about that?
I believe we had talked about that.
Oh, I don't even remember. I'm turning into Maxwell. Maxwell, do you remember that?
What's that?
Well, we heavily questioned it, at the very least.
Huh. Yeah, I don't.
Wait, what are you guys talking about?
Why didn't you listen?
I lost track.
I said whether or not there's a multiverse that's created as you shift through the timeline and change certain actions, or whether or not there's simply a single timeline, so whether or not you go forward or backwards, whatever occurs within it changes that you may have caused that are outside the norm of the actual continuity will still have occurred in that said timeline, and it simply therefore continues to move forward with those new actions in place.
So the single universe occurs without the grandfather ever existing, or without you existing, or the murder ever happening, even though it did.
You know, then that's
So
it.
you mean like say pretty much like shifting universes as you time travel?
No,
Well,
the
no.
opposite of that.
So for a single timeline, if you go back,
so there's only one single
Yeah.
timeline, like
Yeah.
no, the opposite of multiple universes.
yeah,
So instead of just killing yourself and then you don't exist, if you go back and kill your grandfather, then everything from that moment ceases to exist. So you've wrecked everything.
you no longer exist. You
And
can't
and
find
and uh
can't
and some theorists say, like, if you succeed in doing that, the whole paradox can end the planet and end the world, or
Well, no,
like
there is no paradox if that happens because it all happened.
Yeah,
oh
and that's what it is.
oh wait, but
No
oh
one,
oh
no
yeah,
one
but
will.
you wouldn't exist or some shit like that. Like if you
That,
killed your
yes,
grand.
correct. After that, but you did exist before that, and you really did go back in time and kill your grandfather.
Yeah,
Uh,
All right.
oh
So moving on to these different to more paradoxes on astronomytrek.com. There is nothing in Einstein's theories of relativity to rule out time travel, although the very notion of traveling to the past violates one of the most fundamental premises of physics, that of causality. With the laws of cause and effect out the window, there naturally arises a number of inconsistencies associated with time travel. And listed here are some of those paradoxes which have given both scientists and time travel movie buffs alike more than a few sleepless nights over the years. The time travel paradoxes which fall into two broad categories. One, closed causal loops, such as the predestination paradox and the bootstrap paradox, which involve a self existing time loop in which cause and effect run in a repeating circle, but is also internally consistent with the timeline's history. Two, consistency paradoxes, such as the grandfather paradox and other similar variants, such as the Hitler paradox, the Polchinski paradox, which generates a number of timeline inconsistencies related to the possibility of altering the past. All right, let's move on. Paradox one, predestination paradox. A predestination paradox occurs when the actions of a person traveling back in time becomes part of past events and may ultimately cause the event he is trying to prevent to take place. This results in a temporal causality loop in which event one in the past influences event two in the future, time travel to the past, which then causes event one to occur. With this circular loop of events ensuring that history is not altered by the time traveler, and that any attempts to stop something from happening in the past will simply lead to the cause itself instead of stopping it. This paradox suggests that things are always destined to turn out the same way, and whatever has happened must happen. I just got another mind shock from reading that. Did you follow all that, Maxwell?
no, I didn't.
Let's say something bad happens, so then somehow you're able to go back in time and you try to prevent it, but in your trying to prevent it, that's what causes it in the first place, or causes you to want to go back in time. So it's like a loop.
I see.
at least for me personally, I do understand that only because I think I recommended this before for anyone who is interested in our discussions about time travel. They should watch this one show called Continuum, which is essentially all about time travel. And this scenario was one scenario they did play out.
Well, I just got a thought though. So you guys ready for a mind shock?
Mm-hmm.
What if? So let's say some people think Earth is kind of like an organism. It protects itself either by making diseases to cull humans, or in various ways it protects itself in its own existence.
Correct. Right.
What if the universe is the same way? So, what if this loop, this endless loop, is a safety mechanism built into the fabric of the universe for any potential time travelers trying to mess with it? Like it's kind of like a safe defense, like a self-defense mechanism of the universe to protect against time travelers screwing up the natural flow of the universe.
That would be interesting.
Maxwell, did you follow that?
No, can you repeat that?
How come you pay attention when I say it the second time, but not or the third or fourth, but not never the first, or almost never the first?
I don't know.
What if the universe, it's a self-defense mechanism? Whenever somebody goes back in time, it creates that loop so that whatever caused them whatever event they're trying to stop happens anyway, so then they go back to stop it. So the time travelers are always stuck in their little loop, so they can't mess with the greater universe, and then the non-time travelers are free to live in the universe naturally, as it's supposed to be. I mean, it's kind of almost like quarantine. It's almost like a universe quarantine for time travelers. Did
That
you
would be impressive.
did you
So
follow that, Maxwell?
I'm thinking about it. So
but now my
so if
question
I
is: is it a negative or a positive event? Would it affect either one?
Well, I would assume
it doesn't matter because the universe wants to function the way it functions. So anything messing with it is not
Right.
good.
If it's predestined. Okay, I can accept that. So I'm sorry, Maxwell.
What were you saying, Maxwell?
I'm still not following. So if I like time travel backwards
To
10
change an
years,
event, to change an event,
okay, so I change an event. Um,
but then something happens which causes the event. You're stuck in your loop because the reason to change the event is what caused you to time travel, which so you're always looped. Do you remember anything from part one where we talk about like
uh,
remember the girl in the bedroom and her older version comes to her and says you should do this instead, and then she does, but then if
oh
that
yeah,
person
yeah, like the career changer
yeah, whatever.
person.
Yeah,
Like
so
she
whatever.
wanted to be a lawyer or some
Yeah,
shit like
so
that.
whatever causes a loop, it doesn't matter what it is. But if a time traveler messes with something, they go to their younger self and they tell them to do something instead. Then when they grow up, but that time traveler messed it up. And if a closed loop, if that's what it is, that closed loop of they go back. So that event of going back caused their other self to go back to their previous self. So it's like they're trapped in a loop, right? Are you following?
Yeah, yeah. I think they've made movies like that where it just stuck the
They've made a
loops.
whole bunch. But no, the point is, if the universe is trying to protect itself, time travelers are not natural to the universe. So it creates these loops as a way to quarantine time travelers, so they can do their thing in their loop without truly affecting anything in the rest of the world, in the rest of the universe.
I see.
It's like a quarantine.
Yeah, yeah, yeah. Yeah, quarantine the time travelers because
All
they're
right.
fucking
Well,
up the
let's
universe
continue
and
here.
shit.
So, sound
But what
complicated.
if the time traveler is technically a part of the natural order that had to occur?
Well, then that disproves my theory.
That'd be interesting, though.
So, well, actually, not necessarily. This goes with your theory. If it's a time traveler that's doing something beneficial for the universe, maybe it's allowed, and the causal loop doesn't occur. And then the bad ones, kind of like an immune system, it's gonna focus on the pathogen. It's gonna want to kill the pathogens, but it leaves the beneficial, everything beneficial. So if the
What if in the loop the time traveler decides to do the opposite, which is good, that he gets out of the loop?
maybe in this new theory that we're discussing now, yes.
It could occur.
That's cool.
Oh man.
You're a script writer, man.
All right, so sound complicated? Imagine that your lover dies in a hit and run car accident, and you travel back in time to save her from her fate, only to find that on your way to the car accident, you are the one who accidentally runs her over. Your attempt to change the past has therefore resulted in a predestination paradox. One way of dealing with this type of paradox is to assume that the version of events you have experienced are already built into a self consistent version of reality, and that by trying to alter the past, you will only end up fulfilling your role in creating an event in history, not altering. So that's what we discussed. Okay, cinema treatment. In The Time Machine 2002, have you seen that, Maxwell?
Say that title again.
The Time Machine from 2002?
No, I haven't.
It was pretty good, actually.
Is that supposed to be the one based on H.G. Wells' book?
Yes, it was
Is they,
directed. It was directed by. It
was it
was
like a
directed.
chair that fucking spins around and shit like a marble?
It was directed by Simon Wells.
Or is it a relation?
Was that his grandson?
Could be.
He's the great grandson of H.G. Wells.
Oh, wow.
Got my time a little off. All right. So in that movie, Dr. Alexander Hartigan witnesses his fiancee being killed by a mugger, leading him to build a time machine to travel back in time to save her from her fate. His subsequent attempts to save her fail, though, leading him to conclude that I could come back 1,000 times and see her die 1,000 ways. After then traveling centuries into the future to see if a solution has been found to the temporal problem, Hartigan is told by the Uber Morlock, "You build your time machine because of Emma's death. If she had lived, it would never have existed. So how could you use your machine to go back and save her? You are the inescapable result of your tragedy, just as I, the inescapable result of you." That's kind of deep.
That's extremely deep. I like it. But that's right there. It goes with this whole
I
concept
don't
we talked about
remember.
before with cause and effect.
Yeah, I don't even remember that from the movie. I don't remember that line. That's a pretty deep line. Other movies are 12 Monkeys, Time Crimes, The Time Traveler's Wife, and Predestination. Have you seen all those, Maxwell?
No.
For someone who loves time travel movies, you really haven't seen a lot of time travel movies.
I saw the Time Traveler's Wife, all the Back to the Futures.
Oh, okay.
What else? I have seen more, but
Looper.
oh yeah, Looper. I
Did you
love
watch
Looper.
Time Cop yet? We were talking about Time Cop on the previous
Oh,
podcast.
Time Cop. Yeah, I wanted to see that.
Yeah,
I
you gotta
haven't
check
yet.
that out.
Oh wait, that was like with the only theory that's like kind of messed up, right?
That's the same matter can't occupy the same space at the same time.
Yeah.
Oh yeah.
Thinking about it now, though, with the time machine, more than likely with the way this is set up, this must mean that everything that's occurring must be within a single timeline.
Yes.
Just based on given information of what's being said, for the fact that cause and effect has to occur in order to create the time machine. For again, as you said,
Once again, there seem to be laws governing time travel that we don't know about. Which would make sense because, like, let's say you do come up with a time machine. What makes you think you'd just be able to go back in time with the existing law? Like, there's infinite laws of physics that are not discovered yet. Something that's that drastic, why wouldn't it be affected by all these countless other laws that we don't know about? It's kind of weird to think about it from that side of it. But let's move on to the bootstrap paradox. A bootstrap paradox is a type of paradox in which an object, person, or piece of information sent back in time results in an infinite loop where the object has no discernible origin and exists without ever being created. It is also known as the ontological paradox, as ontology is a branch of philosophy concerned with the nature of being or existence. Information. George Lucas, traveling back in time and giving himself the scripts for the Star Wars movies, which he then goes on to direct and gain great fame for, would create a bootstrap paradox involving information, as the scripts have no true point of creation or origin. Person. A bootstrap paradox involving a person would be, say, a 20-year-old male time traveler who goes back 21 years, meets a woman, has an affair, and returns home 3 months later without knowing the woman was pregnant. Her child grows up to be the 20-year-old time traveler who travels back 21 years through time, meets a woman, and so on. American science fiction writer Robert Heinlein wrote a strange short story involving a sexual paradox in his 1959 classic, All You Zombies. These ontological paradoxes imply that the future, present, and past are not defined, thus giving scientists an obvious problem on how to then pinpoint the origin of anything, a word customarily referring to the past but now rendered meaningless. Further questions arise as to how the object data was created and by whom. Nevertheless, Einstein's field equations allow for the possibility of closed time loops, with Kip Thorne, the first theoretical physicist, to recognize traversable wormholes and backwards time travel as being theoretically possible under certain conditions. So some movies, as an example of this, are Somewhere in Time, which we discussed, Bill and Ted's Excellent Adventure, the Terminator movies, and Time Lapse from 2014. I haven't seen Time Lapse. Have you seen Bill and Ted's Excellent Adventure, Maxwell? Is that your favorite movie?
I've only seen clips of it. Some of it, it, it looks interesting. I haven't seen the whole movie. I should watch it.
It's a classic. Sid, have you seen
Wait,
it?
Bill and Ted, right? You said?
Yeah.
Yeah. Like
I
they
have.
go in a fucking phone booth and
Yeah.
fucking they meet like Abraham Lincoln and shit.
Sid, have you seen it?
Yes, I have. Though it has been a while.
Yeah, it's been a while for me too. Quite a while.
Yeah, that's what made Keanu Reeves famous. I think. I don't know. I could be wrong.
Then we
Maybe
have the
something else.
grandfather paradox, which we already discussed. And then let's discuss the let's kill Hitler paradox. Similar to the grandfather paradox, which paradoxically prevents your own birth, the killing Hitler paradox erases your own reason for going back in time to kill him. Furthermore, while killing grandpa might have a limited butterfly effect, killing Hitler would have far reaching consequences for everyone in the world, even if only for the fact you studied him in school. The paradox itself arises from the idea that if you were successful, then there would be no reason to time travel in the first place. If you killed Hitler, then none of his actions would trickle down through history and cause you to want to make this attempt.
Which must be the same rule that the time machine followed.
Yes. So, by far the best treatment for this notion occurred in a Twilight Zone episode called The Cradle of Darkness that sums up the difficulties involved in trying to change history, with another being an episode of Doctor Who called Let's Kill Hitler. You know, for people doing a time travel podcast, I have not seen Doctor Who. Have you guys seen it?
I watched a few episodes.
Maxwell?
I saw a couple.
Oh,
I
okay.
don't know. I didn't find it that interesting for some reason. Oh
Sid.
wait, is it? Wait, I don't. It was a time travel.
Yeah,
Huh.
Sid.
I
What?
don't, yeah, I don't think I've seen it. Yeah.
Sid, what's your take on Doctor Who?
Doctor Who, from what I've seen, very little.
Huh.
Um, Unlike Maxwell, it does seem interesting to me. Just haven't gotten a chance to dedicate myself to watch the many seasons it has.
Oh yeah, yeah, way too many. All right, let's go over Polchinski's paradox. So, American theoretical physicist Joseph Polchinski proposed a time paradox scenario in which a billiard ball enters a wormhole and emerges out the other end in the past just in time to collide with its younger version and stop it from going in the wormhole in the first place. Polchinski's paradox is taken seriously by physicists as there is nothing in Einstein's general relativity to rule out the possibility of time travel, closed time-like curves, CTCs, or tunnels through space-time. Furthermore, it has the advantage of being based upon the laws of motion without having to refer to the indeterministic concept of free will, and so presents a better research method for scientists to think about the paradox. When Joseph Polchinski proposed the paradox, he had Novikov's self-consistency principle in mind, which basically states that while time travel is possible, time paradoxes are forbidden. However, a number of solutions have been formulated to avoid the inconsistencies Polchinski suggested, which essentially involves the billiard ball delivering a blow which changes its younger version's course, but not enough to stop it from entering the wormhole. This solution is related to the timeline protection hypothesis, which states that a probability distortion would occur in order to prevent a paradox from happening. This also helps explain why if you try to time travel and murder your grandfather, something will always happen to make that impossible, thus preserving a consistent version of history. That's pretty interesting, right?
And that would bring up what you had brought earlier, possibly with your theory that what if the universe create these situations like
Well,
almost like an antibody.
that was the quarantine theory where it kind of allows the loop and
Oh, okay.
isolates it. This would say it actually prevents it, almost like to continue with our immune system analogy. It almost injects antibodies to kind of adjust the course in order to prevent, in this case, the critical events are the organism. So in order to save the organism, it kind of sends out these ripples to always prevent any kind of critical attack on a critical instance. Maxwell, did you get all
Sorry, I missed it.
that? Max Alarmy. All right, we got to move on to self-fulfilling prophecies. So you know what always bothered me as a kid? Do you remember in some of those myths, especially Greek myths, that there'd be a warning or some kind of they'd be warned in whatever way that I mean I kind of forgot. Was it Oedipus? It was related to the Oedipus myth where a king was
Oh
told to send away his younger son because or a king was told his
no,
younger
no,
son
his son would come and kill him.
is that Oedipus?
Yes, that was Oedipus
Okay.
Rex.
Oh, got it. All right, cool. Good thing we got
And
Sid Irwin here. He's like the opposite, the opposite of Maxwell Powers.
and
um,
that yes, that's the reason why the king decided to kill his son to prevent him from, of course, fulfilling said prophecy. But in the end, I think the son was saved by some servant and sent away instead.
yeah, but if those ripples, if he had just loved his son instead,
Uh,
would his son have killed him? I mean, maybe if that was destined, but maybe
if he
not.
was dead,
That's
or
like
maybe not.
whenever I read all those myths or other similar myths like that, I would. It used to bother me because it was almost like the fates were messing with people just for the heck of it, almost
But
like
you
a
have
trickster spirit. Whereas it wasn't going to happen, but because they told him that, they made it happen by their own hand,
exactly because it's
trying
a
to avoid
choice.
it. Yeah.
Because if anything, the prophecy could have been sent out like this prophecy is nothing more than a guarantee of what could happen depending on certain actions that you take, aka fine print that isn't mentioned.
Maxwell, any thoughts on this?
What's that?
Why don't you pretend every single time anybody says anything, it's the second time, repeating just specifically for you. But pretend that's what it is on the first time anybody says anything.
All right. Um.
I'll try. That's not a bad
Real quick,
method.
no, no,
So
let me
what's
summarize it. So in Greek myths, sometimes a fate or whoever, an old seer, they would tell someone, "Oh, if your son is going to kill you in the future, and that will be your fate." And that's what will befall you. So the father tries to kill the son, but in those actions lead these ripples that cause the son goes away and then it comes back around and the son eventually kills him. Whereas if he ignored that person and just loved his son, would the son want to kill him later?
I see. So like, it's like that's where the self-fulfilling prophecy kind of
It's
works
like,
in.
yeah, it's almost like in trying to avoid something, you make it happen fast. Like you make it happen, you just make it happen more, or it was
Yeah,
unavoidable no matter what. In which case, it doesn't.
it's the basis of the law of attraction.
So still, it could be discerned about. It could be a
Okay,
matter of also the.
what's your question about this?
Well, we were just talking about how it relates to time travel, which I will read according to Astronomy Trek.
Oh yeah. That's a good point. It does relate to the
Are
time travel thing.
self-fulfilling prophecies paradoxes? A self-fulfilling prophecy is only a causality loop when the prophecy is truly known to happen and events in the future cause effects in the past. Otherwise, the phenomena is not so much a paradox as a case of cause and effect. Say, for instance, an authority figure states that something is inevitable, proper, and true, convincing everyone through persuasive style. People, completely convinced through rhetoric, begin to behave as if the prediction were already true and consequently bring it about through their action. This might be seen best by an example where someone convincingly states, high speed magnetic levitation trains will dominate as the best forms of transportation from the 21st century onward. Jet travel, relying on diminishing fuel supplies, will be reserved for ocean crossing and local flights will be a thing of the past. People now start planning on building networks of high speed trains that run on electricity. Infrastructures gear up to support the needed parts, and the prediction becomes true not because it was truly inevitable, although it is a smart idea, but because people behaved as if it were true. It even works on a smaller scale, the scale of individuals. The basic methodology for all those self help books out in the world is that if you modify your thinking that you are successful, money, career, dating, etc., then with the strengthening of that belief, you start to behave like a successful person. People begin to notice and start to treat you like a successful person. It is a reinforcement feedback loop, and you actually become successful by behaving as if you were. Maxwell, any thoughts on that? I guess that is like the law of attraction, sort of.
To a degree. Actually, basically, yes.
Yeah.
Thinking about that makes me think about what I wanted to say with the just to go back on the Oedipus factor and the choice. Like I said with the self-fulfilled prophecy, it did all of the seer is probably mainly telling him is that your son will end up killing you. Now, as you had said earlier, think of it this way: if the father had loved his son, if anything would could have happened is that the father could have lived a long life. Son could have at some point come to be old enough to become king, and while the father may be dying from a sickness, and the son might kill him. That's more of a mercy.
Oh,
At
I
that
didn't
point
even
in
think
time.
about that. Oh man. Oh
So
man,
again,
that's very interesting thought. So it was yeah.
and like I said, that can tie in with the whole as you talked about with the reinforcement feedback loop of thinking. So if the father thought
So
more of
do
a
you think
positive way,
do you
maybe.
think either fates, prophets, or seers or whatever, it's almost like they're testing the character and nature of a person, whereas what they tell them is true, but they make them think it's a bad thing to test their character to see what they'll do. And if they kind of don't do it because it's the wrong thing to do, then it happens, but it happens in a good way, like you said.
Yeah, like I said, it's usually most of those kind of stories usually are trying to be a test of one's own moral compass and ethical, just basically ethical dilemmas all around.
So let's go over one more thing from Astronomy Trek. Are time paradoxes inevitable? The butterfly effect is a reference to chaos theory, where seemingly trivial changes can have huge cascade reactions over long periods of time. Consequently, the timeline corruption hypothesis states that time travel paradoxes are an unavoidable consequence of time travel, and even insignificant changes may be enough to alter history completely. In one story, a paleontologist, with the help of a time travel device, travels back to the Jurassic period to get photographs of Stegosaurus, Brachiosaurus, Ceratosaurus, and Allosaurus, among other dinosaurs. He knows he can't take samples, so he just takes magnificent pictures from the fixed platform that is positioned precisely to not change anything about the environment. His assistant is about to pick a long blade of grass, but he stops him and explains how nothing must change because of their presence. They finish what they are doing and return to the present, but everything is gone. They reappear in a wild world with no humans and no signs that they ever existed. They fall to the floor of their platform and the only man-made thing in the whole world and lament why we didn't change anything. And there on the heel of the scientist's shoe is a crushed butterfly. The Butterfly Effect is also a movie starring Ashton Kutcher as Evan Trayborn and Amy Smart as Kaylee Miller, where a troubled man has had blackouts during his youth, later explained by him traveling back into his own past and taking charge of his younger body briefly. The movie explores the issue of changing the timeline and how unintended consequences can propagate. Yeah, we didn't talk about the Butterfly Effect movie. That was a really good movie. Have you seen that, Maxwell?
Yeah, I really liked it.
Sid?
I've seen parts, so I did want to see it.
Oh,
I
you
do
have to
know.
watch it. It's possibly, yeah, it's definitely in my top movies for best time travel movies. But you have to watch actually, I would say watch the theatrical version and then watch the director's cut right after, and then watch all the alternate endings to get the complete experience.
All right.
Because it's wacky. It's wacky. Maxwell, have you seen the director's cut?
I don't think so.
I'm not
But
gonna.
I
but it's crazy.
remember liking the Butterfly Effect. It was kind of crazy.
Yeah, you have to watch the director's cut. It'll blow your
I
mind. All right, so solutions. Scientists eager to avoid the paradoxes presented by time travel have come up with a number of ingenious ways in which to present a more consistent version of reality, some of which have been touched upon here, including the solution. Time travel is impossible because of the very paradox it creates. Self-healing hypothesis. Successfully altering events in the past will set off another set of events which will cause the present to remain the same. The multiverse, or many worlds hypothesis, an alternate parallel universe or timeline is created each time an event is altered in the past. And the erased timeline hypothesis, a person traveling to the past would exist in the new timeline, but have their own timeline erased. So we talked about those as well. And the self-healing one we didn't quite touch upon in part one. So that's where whatever happens to either prevent an event or other things happen to equalize. So there's some kind of a homeostasis going on within the laws of the universe that we don't know about that mediate any kind of time travel damage.
I feel like we're definitely covering over this part of the program, and the second part we definitely covered over a little bit more in that. I feel.
So I'm sure Maxwell got a lot out of this podcast. Now he knows all what the paradoxes are and everything about them. Right, Maxwell?
I think Maxwell should be able to start a class now. That way, for any of our
yeah,
future young
I'll start courses.
We need to open up a time travel school. MINDSHOCK University.
With Maxwell Powers.
Professor Maxwell. Oh, man. All right. So we hope you enjoyed another edition of the MINDSHOCK podcast in our time travel series. Once again, if you like the podcast, feel free to donate to our PayPal. Make sure you subscribe to the channel, like our Facebook page, questions, comments, thoughts, leave them in the comments section. Feel free to share the podcast across social media platforms. Like our Facebook page. You can also check us out Twitter, Reddit, Patreon. This is Bruce McGuire signing off.
And Maxwell Powers.
and Sid Irwin.
We'll see you guys next time.
Pretty cool.